houses that we have for different regions around the world. And it is about the latter, the leading houses, that I would like to talk today. What is that about? What is its function, and what it is the connection between the leading house and our region, the Gulf, and particularly the UAE. The Swiss education research and innovation system encourage bottom-up cooperation, which is very much a key word for Switzerland, and not only in research and innovation, which develops directly between universities, institutions, or individual researchers. These direct collaborations are the best guarantee for high-quality research cooperation on equal terms. And that is why the State Secretariat for Education, Research and Innovation commissions selected Swiss institutions like the University of Western Switzerland to set up instruments for cooperation in science and innovation. This has provided to be useful and efficient, a good format for establishing privileged contact and testing new instruments of research and innovation cooperation. To sum up, I would say that the leading house is a fundamental player to further deepen scientific relations between Switzerland and the region, and more specifically between Switzerland and the United Arab Emirates. Having said that, we are working with two pillars when it comes to our cooperation abroad in these specific areas, and the other one, of course, is the SwissNext that Mr. Alini already was presenting, and that has a complementary mission compared to the mission of the leading houses. And this is our scheme that we wish to bring forward to cooperate here now already, and additionally, hopefully, in the future as well. Connecting mind, creating the future was the topic of the Expo. I tell you, when we started a few years ago to put together this Expo, we had eventually the impression it was a kind of a general topic. Now we understand that we cannot take it for granted anymore. Connecting people is something that we have to work on. It's not coming. Naturally. We have to work on it, and I would say we have to work on it on all possible areas of our society. And this is why I'm particularly happy to be here to witness this, wish that we all have to connect people, to additionally connect people also in the field of science, international science. So this is, I think, our mission of all of us. It was a mission for the Expo, and I can say that now that we are in the final rush, it was a successful mission. The Expo as such is successful because it took place. This also, we cannot take it for granted, and because it was successful in terms of participation of people and in terms of partner who connected. Thanks also to the Expo. The challenge ahead of us will be to create a sustainable follow-up for the Expo, starting from this Expo site. We are talking about District 2020, which is the response of the organizer of this Expo in terms of sustainability for this very Expo site, which is supposed to become a new city within 6 months after the end of the Expo. Big challenge. Switzerland, we will try to stand behind together with the Expo during this transitional period, as well. We have been a strong partner of the Expo from the very beginning, first country who confirmed participation, chairman of the steering committee of all country participating. Switzerland is having a major role at this Expo, and now we are hopefully accompanying the Expo towards this transition, and also behind because at least the embassy for sure will remain, and the embassy has the chance to represent almost all institutions of Switzerland in all possible areas, and I tell you, we will continue to strengthen our bilateral relationship with the UAE in many areas, inclusive the area of international science policy. We will have very soon a privileged occasion to do that, because in 23 we are celebrating the 50th anniversary of our bilateral relationship with the UAE, and I can anticipate to you that we are preparing a beautiful program to celebrate this important target, and this will be again like the Swiss Pavilion, a platform for all of you to show the excellence of our relationship with the UAE in so many areas. So the end of the Expo that we are going to celebrate within a few days, it's certainly not the end of a journey. It's the transformation of this journey into another one, and I'm reasonably sure that this also will be a successful story. So thank you so much for being here again. A special welcome to the University of Western Switzerland and the leading house. I wish you good success in your endeavor, and I thank you again very much for giving me the opportunity to participate this morning in this important event. Thank you so much. Thank you.
Ambassador Badji, thank you very much for your opening remarks. Now I would like to invite Mrs. Christine Pirinolli, Vice Rector of Research and Innovation of the University of Applied Sciences of Western Switzerland, to deliver a few opening remarks.
En fait, ils sont en train de diffuser le son. Mais il y a 10 secondes de retard.
Ok, je pense que c'est bon, Christine. Okay, do you hear me?
Yes, we can hear you.
We lost the sound. Do you hear me?
Yes, Mrs. Pirinolli, we can hear you.
Are you hearing me? If you hear me, could you make me a sign? We don't have the sound here in Switzerland. Yes. Okay, sorry for that. His Excellency Massimo Baggi, Ambassador of Switzerland to the United Arab Emirates and Bahrain. Yes. Dear professors and dear representatives of companies, dear colleagues of the Swiss Pavilion and online, ladies and gentlemen. Although a bit difficult because we are online, I am very, very pleased to welcome you in the name of the Rectorate of HESSU, Universities of Applied Sciences and Arts, Western Switzerland, and obviously in the name of the leading house, MENA. Since it is the very first time that the World Expo is organized in the Middle East, it represents a unique opportunity for the leading house, MENA, to present its work and also to strengthen the links with the scientific community, not only in the United Arab Emirates, but in the whole region. HESSU received in 2017 the mandate of Swiss Secretariat for Education, Research and Innovation to manage the leading house for Middle East and North Africa. And as said by the Ambassador Badji, the leading house program has a very strong aim to strengthen the scientific collaboration between Switzerland and region with a high potential. HESSU is the largest university of applied sciences and the second largest higher education institution in Switzerland. Our researchers and lecturers have strong link with the MENA region, and this can be seen through the several projects carried out in cooperation with the partners of several countries. Moreover, scientific collaboration is a key issue for HESSO. Universities of Applied Sciences and Art have a crucial role in the development of international cooperation in the field of practice-oriented science and research. So HESSO has been very proud to represent Swiss Universities of Applied Sciences in the international research community and especially in MENA region. I would like to take this opportunity to present some specificities of the Universities of Applied Sciences and Arts, and our main strength probably is to offer bachelor, master, and long life learning programs with a strong practice-oriented approach. 6 professional areas are covered: art and design, business management and services, engineering and architecture, music and performing arts, health sciences, and social work. Therefore, we have a very strong link with the professional ecosystem, both for the training of our students and for the practice-oriented research and innovation. So you will have the chance to hear an impressive sample of projects in the field of the smart connected city in the panels that will take place this afternoon. We will have the pleasure to hear specialists from Universities of Applied Sciences of Zurich, Northwestern Switzerland, and HESSO, and they will discuss their projects and solutions with scientists from universities of United Arab Emirates and obviously with professionals from companies and institutions for both countries. It is exactly representative of this link we have with the professional ecosystem. Since its creation in 2017, the leading house MENA has supported certified research projects and mobility stays. There were all partnerships between researchers in Swiss institutions and partners in different countries throughout the region. Many applications came from universities in the Gulf countries, and 2 of them received a grant from the leading house. The first one was a project of a master student and research assistant of the University of Sharjah, Ilham Kasseh. She was hosted by Zurich Universities of Applied Sciences for a research stay in 2019. Mrs. Kasseh worked on her project, Quality Assessment of Digital Artifacts for Decentralized Software Application. She worked under the supervision of both Professor Manar Abu Taleb in Sharjah and Dr. Joseph Spillner in Winterthur. What is interesting is that it is an ongoing collaboration, and these 2 scientists also obtained an Innovation Starter grant for their project, Application of Stealth Computing in highly informative sensitive cloud environment. Professor Abu Taleb and Dr. Spillner are both present today with several of their colleagues. Their project will be presented in more detail later this morning, so I would like also to thank them very warmly for their presence and to congratulate them for their fruitful ongoing collaboration, which is a very inspiring example for partnerships between our countries. Today's events will also be an opportunity to discuss the challenges that lay ahead, to think the future of our cities, and the solutions that international teams can develop and implement with industrial partners. In this optic, and for its current mandate, the leading house MENA has extended its activities to all the countries of the region, opening the door to many further collaboration. Mrs. Luna Jacopini, Head of International Affairs at HESSO, will present in detail the instrument that will be offered for the next few years. So I take this opportunity to thank her very warmly for her commitment and her valuable work in developing these partnerships, and I'm particularly very happy that we could go on with partnerships with the MENA region. Anyhow, I hope that today's event will be an opportunity for all the people attending in Dubai and also online to be very much inspired by the stimulating presentations and discussions, and obviously to meet new partners for future collaboration. I wish you a very fruitful and very inspiring event.
Mrs. Pirinelli, thank you very much for your contribution. It's a pleasure to have our colleagues from the HESSO listening to us. It's a shame that you weren't able to make it here, but still, I know that your hearts and all your wills are with us today. Without further ado, I would like to then invite Dr. Joseph Spillner to give a keynote speech to kickstart the substance of today on smarter cities. Dr. Spielner, the floor is yours.
His Excellency, esteemed Vice Rector, dear colleagues and guests, it is a great pleasure for me today to dive with you into a few research aspects behind these collaborations. Let me start by saying that although it is me giving the talk, we have a number of universities present today, and if you ask 10 researchers about the future of smart connected cities, you will get exactly 10 different answers and 10 project proposals on how to proceed. So this is one view, but probably it is containing a few thoughts and a few directions that we can pursue in the follow-up to strengthen those collaborations between the two countries. Now you may also wonder, why is there not a city? Why do we have a village? It's some village in the Thurs Valley in eastern Switzerland. When we are talking about smart cities, well, the title of the event had to be short. Usually we talk about smart cities and regions. There are also people living in rural areas, and we need to make it smart for the entire population. Now your next question may be, why is the topic of the talk cyber physical spaces and not smart connected cities? Are we at the wrong event? No. We are talking about the same substance, but from a different angle. And I would like to dive with you into visions and opportunities. We are in the opportunity district of Expo 2020 here in Dubai, and Switzerland is the country of opportunities. And the visions is something we as researchers can provide, along with, of course, working solutions. So the way we look at that from a political level, the United Nations have defined a number of sustainable development goals. And some of them we will pick up during the day, such as clean water for everybody. We take that very much for granted in Switzerland. Wherever we go, we have wells, we have tap water, we just drink. And we have infrastructure in place to ensure that the quality of the water is sufficient and it's healthy. We know that this is not the case everywhere in the world, and we are working hard to improve that situation. A second topic is resilient infrastructures, especially when we talk about mobility, logistics, transport, even vertical moving, as we have in this pavilion. All of those are nowadays powered by digitalization, by software, and that means if there's an issue with software, everything will stand still, and this is something we cannot afford on the city level, also on the national level. So we are taking the challenges that are coming from those domains, the industrial domains, the companies working on those solutions, the technologies, but also taking people into account. Smart city, if you talk to any smart city manager, they will tell you smart city is about people. And so we need to take the people on board and see who are the stakeholders, what are their preferences, what are their constraints. And of course, a bit of a reflection on my work that I will bring is the computer science aspect. What can we do from a digitalization point of view? So we would like to address the topic of smart connected cities in a, of course, sustainable world. Now if you think about cities or cities and regions, what are they composed of? What do you think of when you hear the word city? You may think of the buildings, of the people in the city, of the cars and trams and trains moving through the city, of the nature that you still find in cities, lots of parks, lots of nature, of course, around the cities, but also of the relations, the social context, the governance structures, and a lot of complex processes. Nowadays, we talk a lot about, for example, circular economy. And that involves a lot of people, a lot of technologies, a lot of buildings. So it's not a singular aspect. We need to have more holistic solutions. And digitalization is really everywhere. And that is increasing, right? So we need to be able to master all the challenges of digitalization. And for us, from a computer science perspective, digitalization is often linked strongly to softwareization. We bring software into anything that has a physical identity and that did not have this software functionality beforehand. And this affects every device that we can imagine. So in Switzerland, we are very proud of some of our traditions, like the Swiss Army knife. Everybody should have a Swiss Army knife because you can use it in all sorts of situations, right? And nowadays, when you buy the Swiss Army knife, it is still the original Swiss Army knife. Now I have the Victorinox model here, but now it's software powered, right? So we have a clock inside, we have a thermometer inside, we have an altimeter inside. We can walk in the mountains and we know where we are. All of that. We cannot yet make phone calls, but I think this will come, huh? So the functionality is growing together. And this is something we need to be aware of, and we should factor into our solutions. So I have taken a vision that has been brought up in the scientific community about what smart cities mean. I have slightly extended it. So we have people, we have those devices or things, we have certain online platforms that are increasingly of strategic importance. You can order a taxi online, but who operates the platform, who has the profits, who is controlling the market shares, that is something to be aware of. Then the complex processes, and of course also the connectivity. It was just mentioned in the opening words, connecting people means also on a technical level we have to ensure that we have connectivity in place. Again, I only know the Swiss perspective. We have 5G coverage everywhere, we have LoRaWAN coverage everywhere, so far away or nearby connections are not a problem in most regions. But we have to think of what kinds of connectivity, also from a sustainability point of view, do we want to afford for which kind of application. Connectivity does not come for free, requires infrastructure, requires energy, maintenance, and so forth. So let me go through a couple of example solutions we built as a university in the previous months, maybe in the last 1 or 2 years. One topic that most of you have, of course, come in contact with is the number of digital solutions to manage the pandemic. And that started very early with some forms online where you had to register if you had a case of COVID, and then the solutions became much more complex. Nowadays we have solutions to register for vaccination, register for testing, tell the airlines in advance where we want to travel, tell the government that we want to enter their country, what kind of vaccination do we have, passenger locator forms. We have, of course, the digital certificates that prove that we are vaccinated or tested. We have the contact tracing in place. All of those solutions were necessary from a societal perspective, depending on the political decisions on each country, which measures to take. And all of them had to be taken under time pressure. A certain pragmatism was necessary. Of course, from a government perspective, if you have 2 weeks to make a decision, you will not go to a university and ask them, go and do a 2 years research project for us, what would be the best solution. Many of those solutions had to be done under time pressure, and I think many of them were done reasonably well, with some things that can be improved, of course. And now that the pandemic is hopefully over, it's about to be over, we have to not lose the focus on those topics. We have to reflect on what could be done better next time, now that we have a bit more time to prepare. So we built a solution that is also usable by other countries, we think, that also represents a bit the federated nature of governments. So in Switzerland, some of these digital activities were done by the federal government, sometimes by the cantonal government, sometimes municipal. We have built a software architecture that allows to reflect political structures into the software. If a cantonal functionality or state functionality, maybe an emirate functionality, single emirate functionality, is supposed to be lifted to the national level, all it should require is a little switch in the software, not completely a new procurement process, a completely new kind of software. So we need the flexibility built into the system, built into the software, this federated nature that we simply have in real life. We need to reflect it in our software architectures. And the issues are everywhere the same, right? When you try to use the official Federal Office of Health scanning application for certificates in Switzerland to scan the QR code, and the QR code has a black background because your phone has a black background, it will not work. If you try to enter Expo, we just had it this morning, and your QR code has a black background, it will not work. From a computer science perspective, this problem has been solved ages ago. but it needs to be implemented. It requires leadership decisions to say we will take the best solution and not the second best. And this is where we need to be heading. I will give you another example which is closely related to what we will discover in the afternoon, water management. So water management used to be a person, maybe a field engineer, going to the water pipes, checking a few measurements, taking numbers in a notebook, reporting back to the headquarters the state of the pipeline or the flow of water. Nowadays we measure systematically with electronic means in a high density, high precision measurements every couple of meters. So this generates a ton of data, and we need proper architectures that are also resilient, because this is critical infrastructure, safety critical also for the country. And we have built such an architecture also in conjunction with industry partners in Switzerland that make it possible to scale out to rather large deployments in the field. And we have published that, as we do as a university, but we also see the market-driven approach to see that implemented in the field and to work with technologies that permit such functionality to be deployed. And often we have custom analytics. For example, in one pipe installation you have a certain metric that you want to generate, and in the next one it's another one. So you need custom functionality on each of those deployments. I will not go too much into the technical details. I think everybody who is interested in those can of course contact us. I would like to mention a third case here, which was already present at this pavilion a couple months ago, which is a smart waste solution. So actually what was present at the pavilion was a smart waste sorting mechanism, and this would be supported by a solution that detects waste and tells you how to dispose it. I brought an example. So this is a Swiss kind of trash from yogurt. So this is PET. So this is recyclable plastics. So where does it go to? Does it go into the PET collection or does it not go into the PET collection? And these are complex processes. We strive to separate our waste as cleanly as possible, but we need guidance to do so. We need advice, and especially if you're a tourist, you're coming to a country, you don't know the local waste sorting rules or logics. By the way, this does not go into the PET collection. So we built a system that uses different sensors, computer vision, but also material sensing, to generate hints at where should this be disposed. It's not a tiny smartphone-based solution. It's rather clumsy, but it points a bit the way. And it's energy efficient in the sense that computer vision, operating a camera, takes energy. So we only activate the compute-intensive and energy-intensive part if there's a movement nearby. There's a movement sensor, motion sensor, and you go nearby the smart bin and you hold your piece of trash and it will activate, and then it will tell you where to put it. I will go into number 4. This is connected to the topic of logistics, also something we will hear about in the afternoon. We did some work. We built up a digital mobility and logistics hub in our university, which is recent work. It's not yet published anything, where we created real-time simulation of transportation across a number of routes. So what we see here in the larger figure is the planned underground network for cargo transportation in Switzerland. And so we can use that system to figure out brokerage scenarios, overload scenarios. There's a lot of cargo coming in one point. The vehicles are autonomously operating. What can go wrong? When a vehicle breaks down, another one needs to overtake. So we have systems in place in research that allows to investigate and to figure out potential solutions a couple of years before the system will be built. So sometimes we have a long duration, and sometimes in the pandemic management we don't have a lot of time to come up with solutions. Now enough for the examples, so I would just like to present something that could be of interest in the context of the leading house manner. As we will hear later, there are a number of possibilities to cooperate, to let Swiss and UAE institutions cooperate, potentially involving other partners as well. And there are many, many different models. And I just want to give one potential model, which especially in this context, in the cyber-physical context, in the context of smart cities, may be useful. And we call it the Outlab concept. So we grow an idea out of a lab. We start in the research lab. You have seen pictures before. It looks a bit messy sometimes. It looks a bit unfinished. And then we go to larger scopes, for example, towards our campus. That is already a production system in that sense. We have to ask for permissions. Can we deploy certain ideas? But this is usually a relatively quick process, and then we can scale up more to the city level, and then we can come towards international collaboration. So here's one example, and I had a lot of talk about this with my colleagues because it seems like across Switzerland we work on similar problems. It is called Mustafa. So Mustafa is our solution to do measurements across a number of sensors and to find out what is the actual value of the measurement. I even brought a demonstrator with you here. So this is a physical exhibit. It looks very messy. Huh? This is real lab work. One of our PhD students has been involved. And we have a system called Demos. This is the green box in the middle. Demos is a Greek word, stands for people. The PhD student is Greek. And this is about the voting. Yeah? So we are very proud of voting in Switzerland, but voting comes from Greek culture. And we try to vote, to have different voting mechanisms that may be helpful if there is disagreement between the sensor nodes. So what I brought here are light sensors, 5 light sensors. A question would, for example, be, what is the level of light in this room? Is it sufficient? Is it good for the eyes, or do we need more light if we want to read? Ideally, all sensors will agree, they will report the same value. They will say 50.5 and a physical unit, and an expert would know, is this sufficient or not? But it may be that the sensors disagree. 3 sensors may give this value, 1 sensor may be completely off. It will give -5. And then we would know we have to ignore that part. And 1 may be just a little bit off. But it may be the correct one. So we do voting, and we learn from the historic data, right? So we have a certain experience about the level of light during the day in previous days. So this is a system that is typical for applied sciences. We had a specific need. We actually started voting about measurements of software quality in a completely different field. We abstracted from that problem, and now we reapply the solution and validate the generic solution into other fields. So we have a little demo video. I'm not sure it can play. Let's try. So this is the PhD student holding our demonstrator, which I brought, actually using the cables to supply it with power. And now, if all of the 5 sensors are covered, we get a flashing message saying we cannot determine the light in the room. But if we cover a part of the sensors, like 3 or 4, depending on what how we configure the system, the measurements run fine. Huh? So only if we cover all 5, then the system starts to signal to us that it can't vote on anything, it doesn't have any input anymore. And so we can have relative majorities, absolute majorities, we can have full consensus among all participants, and we are studying those possibilities. This is unfortunately not so readable at this resolution, so I think we go back to the slides. So here are some more details about the voting. I will not go into details, so anybody who would like to get access to the slides, you are more than welcome to get them afterwards. And now we need to scale up from the research lab. We are always comfortable in our research lab. That's the environment we spend a lot of time in, 8.4 hours a day on paper, maybe more like 12 to 15 hours in reality, because we like working with the technology. But we need to get out. We need to bring it to spaces where we have people, where we have production systems. And so I just brought from Deakin University here the concept of a smart campus. Yeah? Smart campus means all the research fields get to use their campus to try out things at a larger scale. So the architecture people, they can build a new building on the campus. The heating people, they can try different heating systems. And social scientists can check the crowd behavior when there are certain conditions. And perhaps in the context what we mentioned here, we work with sensors. So we can deploy several sensors on our buildings and measure the temperature, but also the CO2, which was quite important now during the pandemic. And so this is what we tried, and there's another video. It's another assistant working with beacons. And by the way, you'll find a beacon just below here. So they are very small. They are like small lighthouses that work on a digital level that can power a lot of applications. So you see he's walking from the red point to the blue point. And as he walks, the signal strength we receive from the red point is decreasing and the blue one is increasing. Not happening immediately and not in a very linear way, but we can now detect that the person is closer to the blue point compared to the red point. Now we also see the measurements are coming in from the green point, even though it's still far away, so the green line is at the bottom. Now as the person is walking, and this is by the way our campus of the School of Engineering in the city of Winterthur, as the person is walking towards the green point, again with a bit of delay, the green line is going up. And you see the thin line, so this is again the voting. So this is voting in practice. We have stacks of 5 beacons at each side, and we want to determine with higher precision where is the person located, without using global technologies like the Global Positioning System, GPS, or other satellite-based systems. Because we need solutions that also work if the global solutions fail. And the locally deployed beacons are one way to achieve that, and for a city, therefore, to achieve a higher degree of digital sovereignty. Thank you. I think we have seen the approach, and we go back to the slides. And now we need to scale up. Yeah? So our campus is still fine, but when we talk to companies and we say we have tried something on campus, they will say, yeah, sure. Every student says that, and every researcher says that. But if we go into the city where the commercial activities happen on the city level, we get to talk on a different level as well. So what you see here is a plan of the city of Winterthur where we are deploying beacons in the shops. And that means as a tourist or as a resident, if you walk through the streets, you can get very precise advice on what is available in the shops. Say you're interested to buy shoes, and you just tell your smartphone, please watch out for a nearby shoe shop, and then you're walking through the street and a shoe shop has such an offer that could be of interest to you, you could receive that offer. Now the ideal map is shown in the upper part, right? So this is like an artist's visualization, but the technology is quite difficult to manage. That's the lower part. It does not look so pretty anymore. The signal strengths are differing. There are many obstacles in the way, buildings around which the signals have to go. So we are looking at building applications which can work in such a setting, but which also are convenient to use. Because as a consumer that wants to shop for shoes, I don't want to learn about different signal strengths, right? This is a completely different domain. And again, we have a video number 3, where we are trying this out. Now this is a time-lapse video to save a bit of time. So the person, we are filming this from the 3rd floor of our institute. The person is walking around the street, and on the right side you see the trace of the person walking across the map, and the connectivity the person still has to the deployed beacons. Now here the beacons are not deployed in the shop, they are just deployed in open spaces. And you see the person running back, and the map is gradually filling up with measurement points. We call it a heat map. So in each point of the map we get a certain signal quality, and that is just the fundamental connectivity layer, and then we build higher level services on top of that, such as on which part of the city do you want to be informed about which offer. So on the left side, you don't quite see, there's a church, and maybe somebody wants to know the history of the church. And that could be an offer, if you're a history-oriented tourist, to learn about the history of each place. And we are actually now looking to build such a system. Thank you for the video. We are looking to build such a system with potential application partners. So for example, there's a plan to have historic sites in the city of Zurich. You're walking there and you get this advice, this information directly on your smartphone if you're interested, but you don't get any such notification. If you say, I'm not interested in history, then you should not receive spam that is not of interest to you. Now I think we need to switch back to the full screen mode. Thank you. So this is what we are building, the system, as I mentioned, and now we need to go beyond the individual city level. We need to turn this into commercial products. So we as a university, we can do a lot. We can build up such systems even for prototypes, for pilots, but we cannot scale out in a way that it becomes a sustainable revenue stream for a company to support also the future research on those topics. So here I would like to bring the example of Proxity. Proxity is a company that works with us to deploy technologies that exactly enable the real-time location-based services, such as digitalizing the fountains in Zurich. So Zurich, city of Zurich, has a very nice guide for fountains, a paper-based guide. You can learn about the history again of each fountain, and is the water drinkable or not, and where do you find the next fountain with drinkable water if you are in a certain location. That's very helpful advice for tourists if it's sunny. It's not as sunny as here, but for us it can be extremely sunny in the city. And reading a paper map is good if you're a person that likes map reading, but a lot of persons are not liking or maybe not always able to read the maps. So you would like to get more direct advice, go this street and then 5 meters to the right and you will come to the fountain with drinkable water. So we are exploring such scenarios, and we have a video in full length in the public space downstairs, but in order to accommodate the time constraints, I will just give you a very brief example of this functionality, which by the way is also deployed here. So in the code that you will see, the QR code that is on the banner downstairs, you will be able to download a demo app and experience some messages related to the pavilion.
This allows you to virtually turn any place, venue, or city into a cyber-physical interactive space that can enhance experience, communication, and awareness. Let's see a demonstration. Before, you'd arrive at a place of interest and would like to learn a bit more about it. Then, you'd have to take your smartphone out and search the web for information about it. You would search one web page, then another, and then another, until you would, hopefully, find one that would satisfy your curiosity. This just takes away from the whole experience. With Proxity, you would arrive at a location, receive a push notification with the relevant information, and learn more about the environment around you without having to go through the hassle. You can learn more and see more while having a more in-depth digital experience.
So using such a commercially relevant basis, coming out of lab technologies, coming out of...
This allows you to virtually turn any place, venue, or city into a...
And at that level we can involve students, for example, so that is what we did. And we had a number of scenarios of playing games in the forest of Zurich using beacons, finding other students that carry beacons in their bag and you have to catch them and then you win the game. Or we had scenarios about blind navigation in the city. Usually we have those markers on the streets, but we always need to think about where do we not have streets, how do blind or vision impaired people navigate, and this could be a solution. So we are looking into those different aspects. The students did a great work in the recent months, and this can be fed back into the product development and product improvements. And this is a good basis for international collaboration, because this can be done here, this can be done in Switzerland, and this could be a basis for a leading house project. And we will learn more about the individual funding instruments later. But this way you can prepare the work on both sides and involve students and exchange. And there are some ideas for international collaboration. Why not study an underground transport along the coast of the Emirates? Now, if a logistics person came here, they would probably scrap the idea, because they would say it's much cheaper, much more efficient to use the water transport, which is an option we don't unfortunately have at that scale in Switzerland. But maybe it's an idea worth exploring. Why not? So let's come together, let's discuss that. Or looking at beacons. When we talk to the airport of Zurich, they say it may be an interesting idea, but nobody has ever done it before, and then there's the usual response in Switzerland, we don't want to be the first ones. But now we see somebody has done it before, and those are the local people. At Dubai airport, baggage tags are used using the same technology, so we have a point of reference, and apparently it seems to work well. I got my bag quickly when I arrived here. And so we have those connection points, and we need to find more of them, and we can look at creating project proposals around those ideas. Now, in the interest of time, I will quickly go over just a few challenges, just very briefly, because we have researchers around and they would like to know, okay, what can I write into the proposal in terms of what will I concretely work on, technical level. There are lots of challenges. I will only go through the left ones, so sustainability, identities, and the legal framework. So first of all, the carbon awareness. Nowadays, if we talk about all the digitalization, softwareization, we need more infrastructure, we need more computing. And it is not equally important whether or not the computing is done at a certain place or a certain time. So researchers are now coming together, and I borrowed the slides from Eve Schooler, who recently gave a talk, very recently at another conference, where she came up with the concept of space shifting or time shifting your computation. So if in any place and time you have the awareness that the energy you consume, specifically the electricity, is of a quality that is not up to standards, let's say it's coal generated electricity, but you know that in the night you may get greener energy, you may have a computation that is not so urgent and you simply shift it to later. So you shift from the day during the night and you execute it later. If that is not an option, it has to be done now. There is the option of space shifting. Let's say you have a computation running in a certain country, and the crucial part of the computation is very energy intensive, and then you move it to another country for that period of computation. The technologies are already there right now, but we need better interfacing with the electricity providers. We need the information about the energy mix. There are countries such as New Zealand that are very advanced, that have real-time information about the energy mix. I can virtually hold my smartphone to the plug and get information about where is the electricity coming from. It's not coming out of the plug, it's coming from somewhere, right? But I would like to know. And we need this in our countries. The second one is identities. We have a lot of devices deployed. We need to think of it as critical infrastructure that needs to be protected. That involves people, devices, platforms. So from a computer science perspective, we talk about digital identities. And here I would like to mention another highlight from Switzerland. We have a lot of those small companies that are not so well known, but that exactly address a specific need. So here we have the Citadel solution, which is one way, very unique way to implement identity and access management for very complex deployments. And they have been very eager to demonstrate that in a way that it's connected to the expo. So if you go to this QR code down there or to the link, citadel.ch/Dubai, you will find information that relates to that event and that explains all of that a bit better than I could do it now in 1 minute. The third challenge is digital sovereignty. There are a lot of technology choices that are often done on cost alone. One is better than the other, or technical parameters, but we also need to think of, if we deploy something now, it may be deployed, and I think in the afternoon we hear about it, it may be deployed in the ground for 20 or 50 years. And we don't get it out so quickly anymore. So what kind of dependencies, what kind of relations do we get into? Without going through all of those technologies, but there are usually a couple of trade-offs to consider, and this is what we should thoroughly do. So usually when we talk about introducing a new technology, and that's again coming back to the leadership and governance processes, it would be a good idea to have some guidance process. Yeah? So a process that involves experts to also tell about the possible consequences of all of this technological advances and all of the softwareization. And that should be interdisciplinary. We need computer scientists that understand how the software work. We need social experts that know how the people's reaction would be, and another set of experts as well. To conclude my talk, I would just like to give two views in practice, and I'm very happy that I got in touch with the Smart City Office of the City of Zurich. They have given me this material that shows how already today water measurements happen in a highly softwareized way, using modern technologies in a way that you can scale up to a whole city. And we will discuss that in the afternoon. And also this way, mobility, which will be another topic. I think outside the pavilion you have just seen, we have this small car, Microlino. And now we also have the Ru from Winterthur, and we have Futuricum and e-truck coming from Switzerland. So within just a few years, a country that has not been known for building cars as much as perhaps some neighboring countries has become one of the leading countries in innovative transport means, innovative vehicles. And we should keep an eye on that. So to conclude, I would like to suggest to all researchers present to build those outlabs, growing from the lab environment to whole cities and regions, to focus on those challenges, the three ones that I went through, but also the other ones I mentioned, and of course to frame that in a context that it can be best worked on by both sides with experts from the United Arab Emirates and from Switzerland, starting with the education of the students to build the capacities so they can help you solving those problems, then going into the research in the lab, spending 15 hours a day there, and then innovating with companies, bringing those solutions to the market, into our cities, into our countries. Thank you very much for listening.
Dr. Spillner, thank you very much for your keynote. Extremely interesting. I think this sets up the tone for this afternoon's discussions. Ladies and gentlemen, we're going to take a 10-minute break. So we will reconvene here at 12:35 UAE time and 9:35 back in Switzerland, CET. Thank you very much. There's coffee outside. You're welcome to take a cup of coffee, enjoy. You can also take your coffee inside. There's water here, so feel at home. Thank you.
Alors moi j'ai activé sur le mien. J'essaye?
Oui, tu peux y aller.
Ok, parfait. Super, excellent. So I will say a few words like this and then I will share my screen and the presentation. Yeah, sure, no problem, no problem. You tell us when we can start. Oh, shit. Qu'est-ce que je dois faire?
J'ouvre la présentation aussi. Je peux prendre le backup avec moi, enfin on peut, mon ordinateur c'est tout à coup.
Oui, comme ça, on est fully covered. Si jamais, puis s'il y a une panne d'électricité, à ce moment-là, ma foi.
Ouais. Ouais, je comprends. Tout ce qui s'arrête de façon préférée. Une quinzaine de problèmes.
Mais peut-être toi, parce que alors là, on ne voit pas du tout, mais ça sert à rien de toute manière qu'on voit.
Alors, je peux mettre, mais on verra tout avec 20-30 secondes de retard. Je peux le mettre, hein, mais
Non. Mais du coup, comment on fait pour savoir quand on parle, quand on
alors,
commence?
oui, on va entendre le son dans la salle, dans Zoom,
Okay.
mais ça sera assez faible.
C'est parfait. Non, alors pas de manière, c'est le décalage qui est.
Il y a ce décalage, donc c'est plus trop autre chose. Je pense que c'est arrivé avec les films.
Oui.
Ladies and gentlemen, welcome back to this day of UAE Swiss Smart Connected Cities Exchange. We're going to have more explanations now on the Leading House MENA tools for collaboration between Switzerland and the MENA region in terms of research funding. So it is a pleasure for me to invite Dr. Juna Jacopini, Head of International Relations of the University of Western Switzerland, to give a presentation. Thank you very much.
Je l'ai mis au maximum.
Oui, tu vois, parce qu'il y a des qui sont en train de parler, on a dû l'entendre.
Okay. Hello, my name is Luna. I'm here in Lausanne. Can you hear me? I hope so. I wanted to briefly say hello to all of you and send a very welcome to all the participants who are joining us today, both in Dubai and virtually. I'm here with Michael, who is the program manager of the Leading House, and as myself, I am the head of international affairs at the HSSO. I will share my screen with the presentation we have prepared about the Leading House, but before doing that, I just wanted to say hello to you in person, because when I will start sharing my screen, you will not see me and only hear my voice. So I thought it was nice to first have the opportunity at least to so that you can see who I am. So I will start sharing my screen now. Okay. Excellent. So here at the HSSO, as you heard this morning from our Vice Rector, Christine Pirinoli, we are managing the Leading House for the MENA region since 2017. Before providing you with an overview of the activities and the instruments available at the Leading House MENA, I would like to provide you with a short overview of the context of the Leading House program. Indeed, the Leading House program is part of the bilateral program implemented by the Swiss State Secretariat for Education, Research and Innovation. Bilateral program aim at promoting and strengthening international partnerships between Switzerland and international partners, of course. There are two main instruments within the bilateral programs: the joint research project, which are managed by the Swiss National Science Foundation, and the Leading House program, which is managed by Swiss Higher Education Institution. Overall, we are talking here of a budget of approximately 50 million Swiss francs for a period of 4 years. So what are the goals of the Leading Houses? Of course, for us, the principal objective is to develop scientific cooperation. Each Leading House is responsible for a specific region in the world, and the aim is really to boost scientific collaboration between the Swiss research community and the research community of the given region. We also have the mandate to promote knowledge among the Swiss educational research and innovation actors, and of course to represent the interests of the Swiss scientific community. There are 5 Leading Houses in Switzerland right now. So the HSSO is in charge of the Leading House MENA. The there is one leading house for Asia, and it is ATH Zurich in charge of it. There is a leading house for South Asia, and the Zurich University of Applied Sciences, and Josef is a professor of this university, is in charge of this region. We do have the leading house for Sub-Saharan Africa, which is managed by TPH and the University of Basel. And then last but not least, the leading house for Latin America, which is managed by our colleagues from the University of St. Gallen. So now I will move on and present you more in details the activities of our leading house, the leading house MENA. As we said, we started our mandate, our activities back in 2017. And at that time, we were really the brand new leading house among the leading house networks, because before there was not a leading house specifically in charge of the MENA region. So the first mandate lasted until 2020, and during this mandate, we decided to focus our activities on 7 priority countries, which are, and you can see them highlighted on the slide, Morocco, Tunisia, Egypt, the occupied Palestinian territories, Lebanon, Qatar, and of course the United Arab Emirates. And since the United Arab Emirates was once of our priority country, this is also the reason why we organized this event within the activity of the Expo. So what did we do during our first mandate? We launched 3 different types of instruments in order to develop scientific collaboration between Switzerland and the country of the MENA region. The first one was a SIGMANI call in order to enhance cooperation with the country in the Mediterranean. In totally, we funded 11 projects within this instrument. We also had a mobility grant for young researchers. And this instrument actually worked both ways. So it was young researchers from the MENA region were eligible to come to Switzerland to do a mobility stay, and young researchers from Switzerland were, of course, eligible to go to the MENA region in order to carry out a short research. All in all, we founded 8 international stays with this instrument. And then the last instrument we launch is the Innovation Starting Grant. We launched it in 2019, and we funded 16 projects with this instrument. So in total, during our first mandate, the leading house MENA funded 35 projects out of roughly 90 applications. So to provide you a little bit with some figure so that you can better understand how we work and the interest that there is in the Swiss research community and the one in the MENA region. And here, a slide that presents you the funded projects organized according to the country and the type of instrument. So you can see that during the first mandate, Morocco was the most popular country. 12 projects were funded in collaboration with researchers from Morocco, followed by Tunisia, Lebanon, Palestine, 2 projects with the United Arab Emirates, led by Professor Spilmer and Professor Manar, and 2 projects with Egypt. Now I will present you the instruments and activity plan for the second mandate. We started the second mandate in 2021, so last year, and we are really right now in implementing several instruments. So when we started the second mandate, we decided to revise a bit our instruments in order to be more effective. We took, of course, into consideration the feedbacks we received from researchers and grantees of the first mandate, and we decided to concentrate our activities and effort on two instruments. The first one is the Research Partnership Grant, which allows to fund projects with a maximum budget of 50,000 Swiss francs and which is open to all type of collaboration. And this is also our yearly instrument, meaning that we will launch this instrument on a yearly basis. We had the first, we launched the first LPG grant in last year, and we are actually right now together with Michael finalizing the selection of the first projects that will be funded. And soon we will launch the second research partnership grant. And then we do have a second instrument. We call it the consolidation grant. In this case, we can fund bigger project. The maximum budget is 40,000 Swiss francs. And in this case, we want to fund it already established collaboration. So a slide that illustrates our working plan. As I said, in 2021, so last year, we launched the first LPG call. This year, we will launch the second one, and 2023 will definitely be the busiest year for the Leading House MENA, because we will launch both a LPG grant and a consolidation grant. So, since for us also one of the goal of this event that we are jointly organized with the SwissNex and the Swiss Pavilion is to foster collaboration between Switzerland and the country in the Gulf region, I would like to spend a few more minutes so that I can present you more in detail how the Research Partnership Grant instrument work. So as I said, the aim of this instrument is to develop new projects. You should really think about this instrument as a seed money project. So where you can get funds in order to put together a first proposal. Of course, the project will not be a big one, but it should help you to prepare more substantial application that can be presented to national and international funding agency. And really the aim is to develop long-term partnerships between Swiss researchers and researchers from the MENA region. I just said this, the call will be launched 3 times, 2021, 2022, and 2023. We have a budget that allows us to fund every time about 10 projects, and of course, if your application is not successful the first time, you are definitely welcome and encouraged to reapply during the next call. Briefly, what are the eligibility criteria of the LPG call? As you can imagine, you must be at least 2 partners, 1 Swiss partner and 1 coming from the MENA region. As far as the Swiss partner is concerned, all type of universities are eligible. In Switzerland, we do have 3 types of university, traditional universities, University of Applied Sciences, such as the HSSO and Teaching University, and on top of that, we have 2 Federal Institute of Technologies, and all these universities are eligible to apply together with public research institutions. Regarding the partners in the MENA region, all accredited university or public research institution are eligible to apply. One difference is that with the second mandate, we decided to open to all countries included in the MENA region. So we do not work anymore with 7 priority countries, but all countries included in the MENA region, and you can see the list here on the slide, there are 17 in total, are eligible to apply. So this is a big difference in comparison to the way we operated during the first mandate. The application process is quite simple. It is the Swiss main applicant that can submit the application. We do have an online platform. This is as well a new tool we developed during the first mandate, and therefore we are very happy to receive feedbacks on how this online platform works for applicants. And we also do have a frequently asked question page on our website that will be upgraded regularly. So basically, there is this platform. You can submit your application through the platform, and in the platform you can work. You can actually work on the application together. So it should be actually quite helpful in order to jointly prepare the application. The selection is done in two phases. First, we check the eligibility of the application. This is done here internally by the Leading House MENA team. And then, if an application is eligible, two external experts will evaluate the application. And finally, there will be a final selection based on the evaluation, on the external evaluation. So, as I said, we are currently finalizing the evaluation of our first RPG call, but in about 2 months, we will launch our second RPG call. So I encourage all the people interested attending this event to submit your application. We will officially launch the call in May. The application will be open until August. And in November, result will be disseminated. Through the RPG grant, as I said, we fund a small project up to 15,000 Swiss francs, with a maximum duration of 12 months. So by March 2024, we do expect to receive the report, both scientific and financial one. So I think that I come to the end of my presentation. So here you can see on this slide our email address, the website, so don't hesitate to get in contact with us. And then now, just to say goodbye, I will stop to share my screen so that you can see me again, because I would like to say bye-bye in person. So, and I also would like to take this opportunity to thank the Swissnex mobile team, and especially Dante Raini, for your support in order to organize this event. Dante, thank you very much. It was a pleasure to collaborate with you, and I do hope that we will have the opportunity to collaborate again in the future. And also to say that if you have questions regarding the activities of the Leading House MENA, the calls, the instruments that we will launch in the future, please don't hesitate to contact us, or during this event today, you can ask your question in the chat, and we will reply there. So having said that, I wish you a fruitful event, and I hope that we will be able to work together in the future. Bye.
Una, thank you very much for these remarks, and it has been a continuous pleasure of collaborating with the Leading House MENA. Thank you very much for your intervention today.
Bye-bye.
Now, ladies and gentlemen, we'll learn a bit more about a concrete case study of one of the success stories of the Leading House MENA applications. So we will have a presentation here given between the collaboration of the ZHAW, the Zurich University of Applied Sciences, and the University of Sharjah. And so on the stage, I would like to ask Dr. Spillner to come, and also invite Professor Abu Talib from the University of Sharjah, and Professor Qasim Nasir from the University of Sharjah. And while we install, I just wanted to mention Expo has been a very important event. We have been doing events since October this year, and so this event is of capital importance for us to build a legacy beyond Expo, to have an interaction here within the United Arab Emirates. Our objective, my dream, is to have, in 5 years' time, to look back, come back to Dubai and see, oh yes, this is a project that we started at Expo. And so I hope, absolutely. This is
submitting one.
fantastic. That's that's great news. Okay, I'll let you to it. Thank you very much.
So I'm a little bit hidden, but I think all of us can be seen. We would like to start this presentation by giving a bit of an overview of University of Sharjah, because the Swiss side you have already seen what we do in research. You have a pretty good idea, but we don't know yet what University of Sharjah does and what their goals are. And with that, I would like to give the floor to Dr. Manar. And I think the slides, not the different slides, the other slide deck for University of Sharjah slides.
So University of Sharjah, as you would see, has established in 1997. Next slide. Yeah, if it would be, that would be easier. Yeah, thank you. I hope it's working. Good. So this is the fabulous campus that we have in the Emirate of Sharjah. The delegation from Swiss, they came and visited us yesterday, and we had a very nice tour with them. I looked to my university in different eye, through their eyes, and we had so much fun to see the 14 colleges spread it horizontally in a very nice university city. It's the largest university in the region. So as you would see, we are pioneer in research, in teaching, and community services. We are trying to do to hit high in the international ranking. We are the third according to the Times Higher Education and fourth according to the QS ranking. But we are the first for the first time in the research this year, in quantity and the quality. So we have around 17,000 students. At the campus, we have around 34,000 students that are alumni from these nice 14 colleges. We do have plenty of programs that has been offered to our students, undergraduate and graduate, and you would see that we exchange international students as well through IASTA program. We did some of them with Dr. Joseph, and they had some of our students in his lab, and we have also some students from other countries in our research labs. So as you would see, we have different 14 colleges that will offer around 111 programs. They are accredited by the Ministry of Education, and many of them, they have also international accreditations. We also offer graduate programs. We have around 3,000 students in masters and PhD in different colleges, in these 14 colleges as well. So we have the accreditation, the international accreditation in research. We have 3 research institutes, one for medical side in dentistry, pharmacy, medicine, health sciences. We have another research institute that covers engineering, computing, and sciences, and the third one that covers social sciences, humanities, and Islamic studies, law, and business. Beneath these 3 research institutes, we have around 8 research centers and 66 research groups. As you would see, we are the first for the first time in the country in terms of research. We used to be the third, but we're really doing a great job. We involve our undergrads into our research labs. We do deliver a high quality and quantity. We have international collaborations with academic universities as well as with the outreach organizations these numbers are speaking louder than anything else, and we have high evidence about these international collaborations. That's including from all places and all countries. Our faculty members are very active. We believe on people. We believe on delivering impact to the community. We are really expanding to have partnerships always from everywhere. I'm delighted and very honored that we did some collaboration with Dr. Joseph. We look forward to submit another one and to expand even with other colleagues who we met yesterday. And we were very amazed to see the different areas that they are working, which is very aligned to our research directions and areas.
Thank you a lot for the introduction words. And now everybody in the room should know what University of Applied Sciences in Zurich does and what University of Sharjah does. And then we see the matching points, but then the question is, how does such a collaboration start? And here at Expo we have a wonderful opportunity to meet. We have Swiss and we have UAE universities, but some times ago when we were starting, we actually needed a messenger. Yeah? So we were starting the collaboration while the Leading House MENA was already set up, but maybe we did not already read about it. It takes for new funding instruments sometimes to trickle down through the universities and to arrive at the researchers' agenda. And as Dr. Manar mentioned, the University of Sharjah is very active in IASTE. So IASTE is an organization that sends students abroad to do internship. Most of the placements of students are at companies, right? So you send them and they end up working at Roche or at other companies in Switzerland that we have seen on the slides. The students also have the option to go into an industrial style research lab. And at Universities of Applied Sciences we can provide exactly that. So at our research lab we are eligible as a placement partner for those students, and this is what was happening. So there were two students, Omar and Mohammed, that were coming to us to university in our city Winterthur in 2018. And I would like to ask my colleagues to tell a little bit about the history of those students, because they know them from the start, and I got to meet them when they were already older students, so to say.
Assalamu alaikum. I'm Professor Qasim Nasser from University of Sharjah. I was in electrical engineering, but I will move to computing next year. I have industrial experience. That's why I'm looking always to applied engineering, because any project without a real application in the field, it's just like putting a paper in the library. No one read it. So our eyes, we are together in different categories. She's computer science, I was from telecommunication backgrounds. But we made it happening that we can have a wide spread of projects, because nowadays computing everywhere, no matter where. And we can see a lot of projects that has this kind of collaboration. And I'm come from telecom sector, so I believe in that. That's why we look at the people who are believing in applied math, applied engineering. So what he mentioned about Mehdi and Muhammad, these two students really, we recognize them through the small projects in undergrad. And I am Frank, I discovered one of them, but my colleague Manar, she discovered another one from computer science. So one from computer science and one from engineering. And they went, really they were good ambassadors for University of Sharjah and for UAE in general, because they represent us, no matter from which university they are, but at least they represent UAE in a global. And I believe, which I felt, and that's why we are here, because they were very good ambassadors. And one of them, he is already now have his own company and working in security, computer security and VPNs, all these kind of apps that he has his own app for VPN and other kind of. So we build, our universities, we are just generate people. We are just generating those, to make them go into the market, go into the industry, and to be ambassadors for the university. And that's the beginning. Yeah, this is a beginning. And it's not only us that we did a great job, but our partner, Professor Professor Splinger, he did a great job, really great job. He was visiting us in the university campus. He lived with us. He was, daily. We eat together, we drink together. We have this kind of social, and that's very important, to do this collaboration. And the other point that I would like, to mention is commitment, because it's not a matter of just a project and the money and collaboration, but it's a commitment from both sides. People should commit to the targets, make sure to be proud of the work that they did together. For students, because we are at the end, we want the student to look at us. If we are not committed to do the work, then they will not, believe in what they are studying. So that's the commitment from both sides, and even my part, we are following them every day. And alhamdulillah, we reached that position. And we have, after we do that, we have another project with Professor Splinger, and that project was on the top technologies. The blockchain, that's one that we did with Ilham, and the other big project, which is really very important project, is about the search in compressed data. That's very interesting. Especially we tried with Prof. Splinger, to deal with a company, or they're having this kind of problem. Gigabit of data, they have to search in it and compressed, and you can imagine that it's how much they have time required to do that. So the science has no limit, and the collaboration has no limits. The only way is how to sit together, have an open-minded, and put all these thoughts together to make it happen, and to be proud of the work that we are together trying. I try to mention what I remember. Thank you very much for this opportunity from, Professor Splinger, and really we are glad to be with you, and we are glad as well to do more collaboration. Yesterday, the team were also met the Chancellor, and as the Chancellor said yesterday, that we are open. The University of Sharjah is open for all of you, especially because we are one team at the end. Thank you very much for listening to me. Thank you.
So this was some years of collaboration compressed in 10 minutes, very impressive. And then we want to look a little bit more on what happened then on the Swiss side. And this is something that, of course, they were listening and they were talking and they were looking at it remotely, but today we can give a little bit more insight, because some of you may want to do such a leading house project and then you figure out what are the people going to do. They arrive and then what? So let's break down the history that was just given. Omar and Mohammed, the two students, were arriving. Sometimes we meet them at the airport, but sometimes they suddenly stand in your office in the morning and you open the door and, hello, who are you? I'm the new student. I will work, and you need to figure out what they are working on. So Omar was working with a colleague of mine. He supervised him on cloud technologies that are very fundamental, a technology that is used by Swisscom, the largest telecommunications network. So this is where we have the very strong link. So Omar was advancing a technology that would have brought immense savings to Swisscom. But of course, you have a student and then you have a huge company. We need to bridge. This takes a bit of time. And then I was supervising Mohammed, and he was working on a number of things, starting very scientific things like literature research, creating systematic literature study, but then also helping to implement quality check tools for software. And that is very important, because we will hear in the afternoon reliability and the critical infrastructure that we manage, and resilience. Those are very critical topics, and those are hard topics. They are not the fancy topics that you can show on slides, but you have people sitting many days figuring out how can we make software quality better so that it is not breaking down every other day. And it's a lot about people. So we have the research topics, but as was mentioned, you need to have an eye for the students that have a potential. And then the students develop further. So Mohammed was with us for a year, and Omar as well. And then afterwards, both have their careers, right? So they advance further. And as was mentioned, Omar is in security. Mohammed was going a similar way, ended up going back to the UAE, ended up going to another country, very international. So once you have done an exchange as part of their leading house, then you are open to go to everywhere and you will be hired everywhere. And now we have a little surprise that even my colleagues don't know. We have a testimonial by Mohammed how he developed after the leading house. So let's play the video. It's very short, but it's very nice to see him talking. Just a few days ago.
Hello, my name is Mohammed Adami. Between 2015 and 2018, I was a bachelor student at University of Sharjah. I started my journey at University of Sharjah as a biotechnology student, but after taking a programming class during my 4th semester, I found myself enjoying programming a lot. I then decided that the best decision for my career was to switch to computer science, and that's what I did. In 2018, thanks to IESTA, which is an international association that helps students around the world find internships to advance their technical experience and promote international understanding, I landed a year-long internship in Switzerland at the Zurich University of Applied Sciences, working with Dr. Josef Spielner. Going to Switzerland was one of the best decisions that I made for my career. It allowed me to take my technical skills to the next level by working on cutting-edge cloud computing technologies. I also got the chance to meet very smart people from diverse backgrounds, thanks to the international environment at the school, and build relationships that last to this day. The experience was also great for my CV. It made my profile very attractive to employers, and I was able to find a high-paying job within a few weeks of my returning to the United Arab Emirates from Switzerland. I would like to take a moment to thank IESTA, University of Sharjah, and Zurich University of Applied Sciences for giving me this amazing opportunity to advance my career. Thank you.
And to add a little bit of a surprise on that, we have the model of lifelong learning. So people work and then sometimes they go back to university. So while we already arrived here, just 2 days ago in my inbox, I got a message from our coordinator of the Swiss-wide master's program in Master of Science and Engineering. Mohammed wants to come back to Switzerland and now progress in the master, going more into scientific topics as well. And I think this collaboration will continue this way. But it's a leading house event. So after the internships ended, as was mentioned, I was going to University of Sharjah and we found a lot of common points and we said we need to intensify that not only on the student level, we need to do that also on the research level. And the leading house, at that time I have come across the first call for the Young Investigator grant, which was specifically with the purpose of sending people in both directions to study more and to help. And that's where Ilham Kasse volunteered, so to say. She had interest to come to Switzerland because her topic was blockchain. Now we do not specifically work on blockchain. In fact, we have never really worked on blockchains. So the exchange can also be complementary. We work on distributed systems in general, in different contexts, for example on cloud computing. And at that time blockchain integration into cloud offerings happened. Right? So all of the large multinational cloud providers, AWS, Google, IBM, all the big names, they started offering blockchain as a service. And we wanted to find out more about that. And having somebody who is passionate about blockchain, coming into a research lab that is very strong, maybe one of the strongest in Switzerland, and cloud computing was a very good match. And it was a very seamless process. We did the application of documents to the leading house, 2 pages maybe, couple of CVs. I think at that time we needed an actual paper-based signature. Maybe this has also changed. And then Ilham just arrived. And we had good luck of finding accommodation for her. And she was in the research lab every day, and really long time. And she was the first one to arrive, and she was there all the time. Very reliable person. And we had a number of outreach activities also. We were invited by the Microsoft Azure meetup in Zurich to present our work, which is usually only industry people go there, right? So it's rare that academics go there. We were invited. We had a joint conference publication. We had a number of activities. Now you don't know Ilham yet, and there's another surprise. We also have a testimonial from Ilham, who, by the way, continued exactly in the research. She will tell about it. You will learn about it.
Hello everyone, my name is Ilham Ahmed Qasi, a PhD student at Reykjavik University in Iceland. I have obtained my bachelor and master degree from the University of Sharjah, where my bachelor was in computer engineering and my master was in computer science. I have worked as a research assistant for OpenUAE Research and Development Group for 3 years. During my work with OpenUAE Research and Development Group, I have gained a lot of valuable research skills, which gave me the opportunity to be a visiting researcher to Service Prototyping Lab, SP Lab, in Zurich University of Applied Sciences. During my visit, I have worked on a project entitled Quality Assessment of Digital Artifacts for Decentralized Software Applications, where I have published a conference paper and I have conducted 2 seminars, one in Zurich and the other one at University of Sharjah. These experiences shaped my career aspiration in becoming a researcher, and I have developed a strong interest in blockchain technology, which motivated me to pursue my PhD program with a focus on software engineering and blockchain technology at Reykjavik University. That's all from my experience. Thank you for listening. Bye.
So you also see the people behind these collaborations and the careers that are shaped. And now she is active publishing. So very good researcher, very good gain for you, this university in Reykjavik. Going through the history, so then I had another trip to Sharjah, and I always like to come back. I mean, there are so many things to do, right? So there's the desert, we had a trip to the desert. In the evening, there's the space center, there's a lot of activities. And the next call came out from the leading house that encouraged the involvement of companies or NGOs. But for us at the University of Applied Sciences, whenever it says involvement of companies, we start listening, because that is what brings the sustainable collaborations also to us. And we were able to meet a company that has offices in Dubai and in Geneva that works, as was mentioned, with a lot of data. Confidential, because it's banks, it's big industry, but you can imagine that it's also about the security and compliance in those industries. You must make sure, if you have any bank data that you process, that the data is not tampered with, that you don't have any malicious activities on your systems. So it's a bit of a security plus big data issue, and that's where where data compression needs to come into play. The cost that such companies have for storing all the data is tremendous, and they are not able to process all of that. If the regulator comes and says, can you guarantee that on the 9th of April of 2 years ago, there was not any attack coming from a certain country on your systems? Because our Secret Service tells that there may be a case. Yeah? How does a company address those regulators? And it's not possible, because if you have all of those years of data, the search process alone will take months. And the regulator says you have 24 hours to give us an answer or we will shut you down. That's what regulators do, right? And so we were looking at very complicated techniques to compress data. And compression itself is not a very fancy topic. It has been researched for decades. But in a way that you can still search in the data. And even faster than without compression. So a number of constraints, but we managed to make it work. We had a workshop then in end of 2019 that we organized jointly, where we had a number of authors presenting similar approaches in New Zealand, very far away. And also such costs are covered by the leading house. So you can have joint workshops, organizations. And now the workshop, by the way, it was the first workshop. Now it has seen its 3rd iteration. This year will go into 4th iteration. So it has also shaped the academic community in a certain direction to combine cloud, IoT, security topics that all are in the same field. We then continued the work, but then the pandemic hit, of course. Beginning of 2020, Leading House project was supposed to come to an end, and thanks to the support of the Leading House and to SERI, they were very generous. They extended the duration so that we could still finish up the loose ends and continue a bit the work. We even started working on a new paper. We did not quite finish, but I mean the basics are there. We can finish at one point. And as a last activity, due to the extension, University of Sharjah had a conference, CCCI, international conference going on. I could not travel there because of the pandemic restrictions, but we submitted another paper related to compression from our research lab. And it was peer-reviewed by international committee.
Best paper award.
And it was very well received by the audience. So I think the collaboration was quite successful also from this point. And then I think in late of last year we finally had to submit all the report because the 2020 mandate of the Leading House was seriously coming to an end, and then that is what we did, and all is fine. So it was a very nice collaboration so far, and we are also open to continue. And I would just like, for those who are maybe technically interested to understand what did we do, I just want to run you through a couple of slides, not so much in detail, just so you get an impression of the actual technical work we did with the students. So this is all computer science. So this is what Mohammed did. He helped us doing a very systematic literature search. The classical way is you make your own spreadsheet of papers that you find, and then you condense it into trends that are going on, technological trends, or you see who is publishing most, which country is the most active. We automated that process. So we have a way to scrape literature and to automate the authorship and the technological topics, the software tools that people are working with, and we are able to update the knowledge about a certain field without much effort. We just rerun the scraper, so to say, and we get an updated view. We did this specifically for some fast technologies, which is function as a service specific cloud technology, which in 2018 was still very young. Now it's very much established and generating billions of revenue, including for companies whose offices I have seen here while coming to the expo area in Dubai Internet City. They're all there, right? So we should talk about this. It was published and it's quite popular. Lots of people download the data set that we published. They are interested. Some graphs, and Mohammed helped to generate the data for the graphs. And that gives us also nice executive overviews, right? So if we want to go into this line of research, we see Switzerland is blue. We have some activity. UAE is gray. There's no, it's of course old data. Maybe this has changed, but from a governance perspective, we can see we are missing out on certain crucial research topics, and we should create some incentives for the universities to get into those topics. Of course, US very strong, other countries are very strong, and the same we can do for other research fields as well. This is the work by Ilham. So she worked on creating computer architectures. If you work with computer scientists, you will always see those figures that are architecture figures. We always say jokingly, this is boxes in boxes, so some lines, some boxes. But those figures make a lot of sense because they structure the way the software works, and it helped Ilham to understand, to focus on the smart contracts, which are the kind of computable parts of decentralized applications and blockchains. And very large numbers, and again we automated the analysis. So previous researchers have done a sample, they have maybe analyzed 5 blockchain applications. We were able to analyze thousands due to the automation entirely developed by Ilham. In such complex graphs, we were the first ones to be able to generate them. In which categories are the most popular blockchain applications? Of course, a lot are in games. This is not surprising, but also, for example, in the financial industry. This is again commercially relevant. Then the topic about compressed data. So on the top picture you see uncompressed data. This is how a log file looks like. On the bottom You see in a compressed picture, you can't read anything as a human. But we developed algorithm that can see like an X-ray into this compressed data. And again, we were able to generate a lot of graphs, and we were able to compare, and to bring a bit of smartness and intelligence into that, we also created an advisory service. So imagine that you're working with a company, you have a lot of data that is produced, and you need certain characteristics, so maybe one file needs to be searchable, the other one not. What are the best compression algorithms that you should use in order to be the best in terms of compression ratio, or the best in terms of search time if you want to search? So far this is a manual process. It requires days of experimenting, weeks of fine-tuning. We built an advisory service that you just ask. It's like an oracle. You ask it, what should I do? And it will give you the right answer. And again, a bit on the unpublished work. You're the first ones to see that because it's unpublished. Is we were looking at what are the best compression techniques, especially for log-structured data. That is data that is produced by a lot of internet appliances, all of the communication that happens when we make a phone call, we communicate with the cell tower is going to create a log file, the mobile phone is internally creating a log file, and those are log-structured information, and we have certain ways to work with that, and we created a middleware to make all of that easier. That could be turned into a product if we transfer to a company. This was just a very quick technical rundown, so you get a bit of an impression of the technical work we did. Of course, all of that was included also in our reports to the leading house, so that is a good habit. Then you inform what you did, and then this justifies, I think, also then the next grant that you apply for. Conclusion? Any questions? I'm not sure we have time for questions, probably not.
Any questions?
But I think we go into the break, and then we are available so that you ask, in case you apply, want to apply, you can get all the experience from us that we have just summarized now briefly.
Ladies and gentlemen, thank you very much for this beautiful case study of links between the UAE and Switzerland. Right now, I'm very pleased to say we are on Swiss timing, which is beautiful. So we now have 1 hour break. Lunch will be served outside. You're more than welcome to go outside, have lunch outside if you're too warm. I think the weather, we're quite lucky. It's not that warm, it's windy, it's nice. So you're welcome to enjoy outside. You can bring it inside if you want to. We will start again at 2:30. That's 11:30 back in Switzerland with a fascinating panel on smart water management. Thank you very much and see you later. And also one thing with these red badges, it gives you fast track access to the Swiss Pavilion. So in the meantime, you can go and have a look and visit the pavilion during the break. Thank you. Ladies and gentlemen, very warm welcome back to our event this afternoon. Thank you very much for being here with us. For also our guests who are watching us from Switzerland and from all over the world. In the morning, we introduced the different concepts of the leading house MENA, the different instruments, and also a case study, a collaboration between the Zurich University of Applied Sciences and our colleagues here from the University of Sharjah. And this afternoon, through two interactive panels, we will have a look at more substance on how we can really understand the ICT and have it seen into applied circumstances, applied situations. And for this panel, we will be looking at smart water management. And this is an extremely relevant panel. It is a shared issue that we are all sharing. And this is the occasion to learn a bit more about what ICT, how can collaborations into research, education and innovation bring in terms of solutions. So without further ado, I will leave the floor to the moderator for this session, Dr. Josef Spillner. Thank you very much.
Thank you a lot, Dante, for the introduction. First of all, apologies for seeing me again on stage. That was not planned. We had planned for a different moderator, but just before the Expo event, we got, unfortunately, a number of reports to us of either confirmed COVID cases or suspected COVID cases. Even in the night, we got a few messages saying, unfortunately, cannot come to the event. I have fever or I'm coughing, and maybe we don't want to risk. We don't want to put all of us at risk. So I will jump in as the moderator, of course, knowing the topic very well. And I'm first of all very, very pleased to have such a high profile panel. We have 4 panelists on this first panel. And I'm probably on very thin ice if I say this is a highly diverse panel. This is a panel of different backgrounds. Of course, we bring in also more diversity than in the second panel. So maybe across the 2 panels, we really have diversity in all of the definitions of the word. Nevertheless, we have 4 people who are really experts in their domain, much more than any of us probably, and that look at the problems that are coming, that are defined by the United Nations and by the governments in water management from different technological angles, especially ICT. We start by introducing the panelists. Each panelist has 5 minutes to introduce the profile, just to give a bit of a view also to you on who is now sitting on stage, what could they contribute to the topic, and then we come to a number of hard questions. Maybe starting easy and then going harder to see if we already today have the answers to some of the questions, or maybe we are close to that, or maybe it takes 1 more year. And we go according to the order in the program. So the first one to introduce himself would be Professor Pierre-André Moudry from the HSSO, and I will hand over the microphone.
Thank you very much, Joseph. Hello, everyone. So first of all, I would like to thank SwissNext for having us today, and for the Leading House MENA for organizing this event today with SwissNext. So I'm Pierre-André Moudry from the HESSO, so from the western part of Switzerland. I'm a full professor in systems engineering, and I have a background in computer science. I am part of the data research group, and in this group what we are trying to do is to find ways to acquire data in different types of environments. There should be a slide there. There it is. Thank you very much. So we are trying to focus on either low performance or high performance embedded systems, low power systems, or high performance systems using computing with Edge AI. So the idea is that when you have a sensor, sometimes you don't have either the bandwidth or the energy to transmit the data. So you try to do as much as possible on the sensor itself. And we are doing this with different techniques, among other neural networks. And today we are going to talk about water, And in this domain, we have worked on different kind of projects in smart agriculture, in smart water, also in snow monitoring, but it doesn't really make sense here to talk about that today, also in traffic recognition and snow detection. So maybe we can switch to the next slide. So this is the kind of environment that we are monitoring. So we have here a field where farmers are growing hay in this case, and the question is, how can you monitor such a system in such an environment? Because as you can see here, it's in the heart of the Swiss mountains in the valley near the region of Verbier, and we have this situation here, and we want to monitor the irrigation network. So maybe you can switch. And of course, you see such a network is made of pipes, is made of reservoirs, is made of water inlets, as you can see on the right-hand side of the picture. And of course, you cannot monitor such a network by modifying it, because it costs a lot to modify anything. You have to do work to change the concrete, for instance, and this is not feasible. We have 3,000 such canes to monitor, and a whole network to monitor with reservoirs, etc., etc. And in irrigation, it's a bit different than from drinking water, because in drinking water, of course, you have revenues, you have monitoring which is in place to be sure that the quality of the water is there, for instance, but it is a bit different for agriculture and irrigation. So you don't want to have too costly devices. Of course, you have no power. As you can see here, there is no power available. You have no connectivity, or very bad connectivity. There is no internet there, or even sometimes no GSM coverage. So you have to find a way to be able to retrieve the data from those sensors. And this is the kind of work we are working on in my group in field monitoring, in harsh condition, I would say. It is not harsh because the environment is difficult, although there are some difficulties to overcome, but we have a lot of constraints. For instance, here in the pipes you have 30 bars of pressure, and you have sediments. Of course, you have small rocks, and you have to find ways to measure, for instance, water flows. You have to find ways to monitor the height of reservoirs and pressure in the pipes, etc., and have it in a relatively low-cost system. So we have devised different kind of devices. This is one here that we present, a connected low-cost non-intrusive flow meter. We have different type of sensors. This one will be has been presented in a conference last October, and the paper will be published in a few days. So the idea here is that we have small sensors that cost less than 15 Swiss francs. So that's roughly 60 dirhams. And we device the sensor using vibrometers and accelerometers to measure water flows. Of course, you don't have the same precision as big sensors, but or more costly sensors, I would say. But still, we have a precision of roughly 7% precision in pipes, and we are doing this with machine learning, and we tune the model to be able to measure water flows. Here you can see on a picture there are 4 of those devices on the pipe in the lab, and maybe later we can discuss how this approach in the lab was put in the field, and maybe sometime in a commercial product. So that was it. Thank you very much.
Yes, hello everybody. My name is, so first of all, sorry for my French accent maybe, so if you don't understand, you just interrupt me. My name is Nabil Abdelnader, so I'm also professor from the same university as Pierre-André, which is HESSO. So I come from high performance and parallel distributed community. I worked for several years on deploying e-science applications on large-scale distributed systems, grid computing, cloud computing, and then since a few years I'm working on the deployment, same thing, almost, deployment of what we call modern IoT applications on IoT infrastructure and edge-to-cloud computing. Modern IoT application is something which is which could be defined by this application that are context-aware, meaning that they should react to their context. They should be self-adaptive, and they often deployed on edge-to-cloud computing. Maybe here we have few projects in which on which I'm working related to this modern IoT application. The first one is this smart public lighting. So we have to regulate the traffic, let's say the public lighting regarding the traffic, the road traffic. So you see there is a camera, and then you have this edge device that should recognize vehicles and then count the vehicles, and according to that regulate the public light. Then you have another application or another project which consists on developing a noise radar. It's a kind of a noise sensor which is blind, without any camera, that recognize or classify vehicles according to the noise they generate. And the last one, which is related to smart grid and renewable energies, consists on predicting the consumptions and production at the level of households and microgrid. This is very important if you'd like to develop high-level end-user services, digital services, for example, trading energy between different consumers, or what we call today prosumers. So if you are consumers, if I'm producer, we can set up together a kind of negotiate the rate in order to deliver for you this surplus of energy I can provide. Could be also other types of services like guarantee the stability of a microgrid or guarantee the flexibility of the microgrid. Another type of modern IoT applications coming from agriculture but applied for water management. This is a small project we have had with Tunisian partners, which is funded by this MENA leading house. So it consists on, the goal is to, I will give more detail maybe later, but the goal is to measure the impact of the vegetarian covers with respect to the water consumption. And finally, this is more an early stage idea that I would like to discuss with you related to vertical farming. Someone recognize this figure there? Babylon, yes. Yes, it's Babylon because everyone today is talking about vertical farming as if we have something which is new, which is not true, because our predecessor already made it in Babylon. So maybe we should discuss this later on. Thank you.
Thank you, and good afternoon, everyone. My name is Marcel Meili, and I'm lecturer at the Zurich University of Applied Sciences in Winterthur, that's in the canton of Zurich. And I also lead a research group in the area of low-power wireless embedded systems. And we especially look into using microcontrollers, using sensors, using communication in environments where it is difficult to bring in external power sources. And it means we will not use mains or whenever possible. And if we use battery, we try to use them for as long as possible, or we harvest energy. In our institute, we are involved in many applications, and some of them are in display there. This, oops, sorry, Joseph. This the right on your left top. This is the water project that we will talk a little bit more about later. And if you go on the left, on your left down, that's smart farming project. Then in the middle we have an application related to indoor, and then we have security systems, microcontrollers and security. We have machine learning for food waste management, and we have real-time platforms. Now, this is the application that interests us the most today. The problem, and we are looking here mostly at drinking water, the problem that we've had for many years is that a lot of water is wasted, and often wasted because we don't even know that water is being lost. And there's a big infrastructure, hundreds of kilometers of pipes and other instruments that are used to bring to us the water that we drink. And if a pipe bursts, you will see it, you will alert the authorities, and they will come and then they will fix it. But a lot of it is not seen. So what we try to do is to make those pipes visible, or to make those problems visible. But how do you make it visible when you are piped down 1.50 meters and that are buried for many, many years? How do you do that? Well, you dig everywhere, right? That will give a lot of job to everybody, but it's going to take us a lot of time to do that. So what do you do? And the approach that we've taken here is to harvest energy locally, to have nodes that will harvest energy using temperature difference exactly where they are, and with that energy they will use smart systems, well, a sensor, a microcontroller, to make some measurements, and then they will beam the result up through the 1.50 meters of soil. And those results will then be collected by stations that will then crunch the data and extract what is important. And as you can see, we've buried nodes, we've had nodes in manholes, and we've had sensors such as flow meters that we've tested, and other things as well. And we work here, the partners in this are the EAVAC, that's the research institute in Switzerland that deals with water. Georg Fischer Piping System, that's an industrial partner. Then the city of Winterthur, where our university is, that's a utility. Those are the people that look that we get water. And then the research partner is our university. And we work, of course, with many others who will come round.
Okay, also welcome from my side. Really feeling honored to sit on this podium as non-professor and also from completely different background as we are now from Anderson Hauser or working for Anderson Hauser. We are producing the instrumentation which is down there already today. Not in this way he would like to have it, still the old traditional way with wired and powered. Main power is has to bring from outside. We are also looking into battery powered devices wherever possible, because this is the new trend to have more of them in the network. As you can see, I'm already here 10 years in the region, a couple of more years with the company in different positions. The last adventure is now, since roughly 2 years, is about digitalization, how the customers and also the consumers are really digitally connected to Anderson Hauser. This starts from selecting the device over purchasing it, putting it into the ground, operating it, and use it later on in the MRO phase, where are all digital touch points. So this is where I'm looking after it, to say, okay, we have a long journey for a customer of us, where it is not just buying or using the output of the instrument. So what we have, and what we also look into it, and this is really the water networks, to say, okay, we have to have certain measuring points to look and understand what is going on in the network. So this is here in Dubai with DIVA as the main water supplier. And they want to measure, okay, what they put into the network, where it is the consumer, whom I can charge. And on the way,
I have a few measuring points, but here we have still the limitation of we need to have the power supply there, either solar power or any main power to get the data out. So this is where we are today. Looking forward that your research is coming into reality and we can really put more measuring points out there, because this is the new trend, first of all, to measure more often. And this is here what we have at the moment is quantity. So we measure the flow and maybe the pressure in the network. But also nowadays we see more and more that the customer wants to see, okay, what is the quality of the water in the network, and not only where I put it in, so also along the network, so that the end consumer can be sure that the water which is coming out of the pipe is still as good as it was put into the pipe. And this is coming into what we just heard. When there is a leakage, we have also contamination of the water, and in most cases it is so small that you don't see it. It is not a pipe burst, and then it is really to look into the network, what is going on. Here we have then the solution for, with the existing measuring principles, to get this data out, collect it, put it then via different ways into the cloud, and then analyze those data and try with the AI to understand what is going on in the network. So also there to learn where is the consumption, because also a network, water network, it never stops. There is always a consumer, and therefore you don't know if it is now consumed or is it a leakage. And there over time you have to understand what is the consumption, what is the trend, and then to say, okay, there might be a leakage somewhere. So this is the challenge, to find out in this high dynamic network if there is a leakage, and when there is one, where it is. So therefore you have to have just more measuring points, and as I mentioned also the quality is now coming more and more into it. And from Endresen we have on the right side, as you can see, the first two developed or products really with a battery powered 3G, in this case 3 or 4G, with a SIM card inside to transmit the data. So we need a certain coverage, but at least you can put it wherever you want, level or flow in this case, put it there and start it up, and you can measure and get the data into the cloud. So this is how we can really support there more on deploying more measuring points. Flow meter is always the challenge, we just discussed in the break. The flow meter itself is a piece of the pipe. So you have to open the pipe, you have to cut the pipe, you have to put the thing in, and it has to operate as long as possible. So we have done, also this is not only on the screen, on the nice slide, so this is really a live product project which we have executed. As you can see on the picture, is also back in Switzerland, where we really deployed more measuring points, and just due to these ones they could really retrieve the data more often than just going around to collect it manually. So they had really visibility 24/7 and could really find out in the first weeks of deploying the software and analyzing the data, we have so many leakages all over the place. So now they are running after them to fix them. Before they didn't knew that they are there, because it is not bursts of pipes. So this is where we are going and heading to.
Thanks to all four panelists for the self-introductions. It was sometimes already a bit more than a self-introduction, but it brought nice topics and nice points up that we can go deeper into. I would like to start with a very simple question, and that comes from this, top-down approach of the UN SDGs. So imagine that the General Secretary of the United Nations would join us today, and he would ask, can you give a very sober assessment of your work? Does your research work for the researchers, or your product work for Endresen Hauser, contribute to solving the water crisis and all the water-related problems in the world? And the investment made into it, which is mostly government money for the universities, and of course the reinvestment of profits for any company, is it worth it? Do we need more R&D activities, or are we good? We just need to stop all R&D and bring more systems into the field. And maybe now we go the reverse order for answering to the microphone. We'll just pass on.
Okay, thank you for the question. Interesting How to answer that one? Let's say as a manufacturer, I would say yes, put just more into the ground, gives more revenue for the company, which helps only a few people. I would say still with more measuring points, it will allow you to manage more, because as long as you don't measure, you don't know what is going on. So therefore, I would still suggest to have more measuring points to understand really what is happening in the network, if you are talking really on the water supply network. Even if we extend this now, not here, but also here we have sometimes flooding, so you have also there water coming on the surface water, which needs to be controlled, channeled, and utilized the best way. So also here we need more measuring points to understand really what is going on. So therefore, more measuring points will not only help our company, but also helps the divas of this water networks to really understand what is happening, to react correctly, and also maybe then with AI on top, really forecasting what might happen in the future.
Well, I would say that we have passed the early proof, concept proof on our side, but it's still research work, it's still ongoing. There've been a lot of challenges. How do you get the data out? You know, if you're in a manhole, it's already difficult because of the construction around, and if you are 1.50 meters down, it's difficult. So we've had to go through this, and also how much energy do you get down there? But basically, you need more points. You need more points to make the measurements, and you need them at an acceptable cost. And the approach that we've taken is locally harvest the energy locally, because we recognize you cannot bring the cables and then also get a signal out. So we can do that today. We can harvest, we can get the data out, and we are now measuring. And because of the way that the whole harvesting works, it normally takes us a whole year cycle to measure the efficiency over all the 4 seasons. So it's going to take some time, but we are moving there, and we are convinced that this is the approach that is going to be ultimately bring us many points.
I would say we need more multidisciplinary projects, because we are dealing with complex problems. So it's not only digital or IT stuff. We need water management experts. If we deal with agriculture, we need agriculture expert. We need business guy to invent or to create a kind of a business model, sustainable business model. We need also to guarantee that the solutions we are developing will be accepted by the user. This is what we call today social acceptability, because it's not sure that what we'll invent will be accepted by the customer or by the users. I think it's very important to have this multidisciplinary point of view or perspective.
Well, in my opinion, what the projects we did changed or gave us as information is that the work we did raised awareness to the different stakeholders, because as Nabil just said, we were working with farmers, with utilities, and of course we are engineers, so we tried to find a solution, as you said, to know how to optimize or to reduce the water consumption for agriculture is very important, because agriculture is where most of the water is used nowadays. And of course you need to measure, you need to know how much water goes into the network, where it leaks, for instance, but also where it is used by farmers, because farmers have ways to know when to irrigate the crops. But sometimes, especially in Switzerland, because there is a lot of water now, the farmers, what they do is they turn on the jets in the morning when the other farmers turn on the jets, and they leave that running until the other farmers cut it, because there is lots of water and there is no problem with the amount of water they have. But as we know, in Switzerland, the climate change will have a profound impact on those type of patterns in the future, because there will be less water in August and July, where the crops need the most water, and there will be more water in spring. So that will need to change. And of course, we need to take everyone into the process, because you can't simply go to farmers and say, okay, now you have to change the way you do it, because that will not work. And we are trying an approach within those projects, is the Living Lab approach, in which we have all the stakeholders together, sit at a table to understand what they do. First of all, because to understand, I'm not a farmer myself. I don't know when I have to irrigate the crops and how it goes. What is the difference between hay and corn irrigation, for instance? So we had those people inside the discussion, and that was very interesting to see that they are very open to solution, as long as they are not too expensive, and also there must be not too complicated, because otherwise it's not worth it. It is important that the systems that we devise do not change too much the way they work. Okay, you can give an advice to a farmer to say, okay, maybe it's an idea tomorrow to irrigate the crops because the weather will be very hot, so and the crops are very low hydrated now, but for that you need to measure the soil. You need to be able to conjugate the information from the weather, from the soil, maybe also from the water reserve that you have, because for irrigation, at least in the field where we were, there is a different irrigation network for irrigation and for drinking water. So these are two different networks, and some of this water is reserved for firemen, for instance, for having water to turn off fires, and this goes against the idea to use it for irrigation, but also this is also in competition with hydraulic electricity generation, because if you use water to irrigate the crops, then you don't have water to turbine and get electricity out of it. So in the end, I think what we learned in this project is that, okay, there are difficulties and very interesting challenges in terms of engineering and computation, but the main problem is not there, is to have all the people around the table and discuss that. So that was maybe the main lesson learned from all those projects, at least on my side. Thank you.
So that was very insightful. I think we need to put all of this knowledge into reports so that we can bubble it up to the UN. And the same for other countries, right? No, we will not have so much time to go into all of the details of all of what was raised, but I would like to go a little bit deeper now on a more individual basis on some of the points that were raised. And I guess some of you in the audience also have questions now, and please keep your questions in mind. We will come to that. We will have the option to ask our panelists as well. But some of that, I'm quite curious, and I guess some of you are as well. That sounds very promising, but we need to know a bit more. And I would like to start with the energy harvesting. That sounds like magic, right? You put a sensor on the ground, and the sensor powers itself. It's like the next version of Perpetuum mobile. And as we know from solar or wind generation, all of the renewables, they have strong fluctuations. So sometimes they work well, sometimes they work less well. And what is of interest to me now is how well does the energy harvesting work? What amounts are we talking about? And how stable is the generation over time? And I suggest we also involve now the second microphone. I discovered it so that it's a bit easier to juggle around.
Is it on? No. Just talk. I just talk, yes. Great. Okay. Well, this is certainly one of the biggest research issue. There's a communication, and then there is the energy. How much do you get? And and how stable, how often do you get it. And as you said correctly, it goes through cycles. And I will not go into all the details here, but basically when we're using thermoelectric generators, we're talking about temperature gradients. It means there has to be a temperature difference between 2 points. And that temperature difference changes. It changes with time, it changes with the seasons. And it means that there are times when we will get a lot of energy and there are times when we'll not get a lot of energy. Roughly today, I will say, with what we measure, we see we can make about 30 measurements, on average 30 measurements per day, and transmit them. And that will be, for each measurement and transmission, we'll need between 100 and 200 millijoules. And this is enough for many low power sensors and for the communication.
So now we need to look at this from the opposite direction. We know what we can produce and how stable it is, more or less. Now we look from the needs side. So in the systems that are put into the ground, is such an amount that he just quoted, is it sufficient? How much lower can we bring the need of all the equipment so that such technology coming currently from the research lab could also be deployed more in the field? Do you see a large gap, or is it more a smaller gap?
Yeah, from the energy amount which we have available, I'm not too much into the development of and the measuring principles. It sounds quite low for my understanding, as we need that energy for measurement and transmission, and we are talking about underground. And as he just mentioned, we have around 30 measurements, which is once per hour. So I'm not sure if that is giving us the most accuracy on over that period, because for 59 minutes we are dead. We are not knowing what is going on. If it is a stable network on a consumer network, yes, it will work, because you have not too much fluctuation. So once an hour can be okay. As more often we can do, as better it becomes the data. So more data is better, but once per hour is already a good indication what is going on if you have a stable network behind. From the energy point of view, to measure and transmit, I would say that is the challenge is on.
And a follow-up question, so you mentioned we need more measurement points, and the customers, I guess, are asking for that. They want more insights into their data flows, right? So can we again talk about numbers? Is it currently, are we talking about 1 point of measurement each kilometer, or are we in the meters, or what are we talking about?
There, at the moment, we are not talking about what is the distance. It is really on the design on the network. So if you have now the source of the water, and you have one big pipeline going down the hill in Switzerland, or here from desalination, you will go to one area and then you start distributing. The moment you start distributing, every line you should measure, because only then you know which line is consuming what. That would be, let's say, the perfect one. At the end, we know exactly that DIVA and none of the water producer wants to install at each junction 1 meter. So you will find some compromises, or to say, okay, that area is maybe not that important. 1 meter is enough for covering the whole area. So this is something to learn from, and then to say, okay, how important and what consumers I expect behind. Therefore, it is not a rule of thumb to say every 100 meters one measuring device. This really needs to look into it from the network, where it goes, what it is used for. And then also, as we learned here before, also here in Dubai, even as you see a lot of greens and green gardens and the greeneries, also there we have a separate network which is supplied by cleaned water, by processed by water from the wastewater plant to be used for that one, so that is not a drinkable water. So also here we have 2 systems in certain areas where already this kind of water which is cleaned is being used, and not fresh water which you could drink. But therefore, for how to put it into place, you have to look at the plan and then decide which point to measure.
That sounds all very insightful. I guess we have already learned quite a bit today. Now I would like to open the floor. came to the panel with a certain expectation. These people would talk about something. So if you have anything, please raise your hand, and then you will be able to ask a question. Yes.
Thank you all. Really, I am just looking outside the box, not. So when I just listened to what you are saying, we have to look at the future. We have to have specs for the smart pipes. I mean, I think it's a good idea to think about standardization of the water pipes in the future. Now, most of the pipes are end of life. You have to replace them anyways. And when you replace them, you will get the same trouble again of measuring and monitoring and looking at more points. So I believe from our side, we have to think about standardization, about smart pipes, at least water pipes, which include all these kind of experiences from companies, from research, where to put them there. So whenever one will buy or will install a new pipelines, then we have to take care or take into consideration those kind of ideas to put them smart. In this case, no need to have a problem of 1 meter 50 centimeters again and digging and installation, because I believe it will come one time to remove the old ones, put the new ones, no matter what's the size. That's one thing came to my mind. The second point, which I'm sure there is, because I have a little experience in that, is about using radar technology. I mean, there are penetration radars that you can look under the ground, and from RF side, from the radar side, lidars, radars, or other kinds, where you don't need all this kind of doing with the help of GIS, because in GIS, we know all the pipes, where are they located? Big ones, small ones, the whole network, I can see it visualized on the GIS. For every municipality, they have it. One section for GIS. So all the pipes, and they can use now drones with the radars or with the not radars or lidars, and then they can discover under the ground what is going on under this ground, because you cannot see it. Now you can see it by radar, and in this case you change the whole ideas. Maybe it's a good line of research where you can look at it if this makes sense. Maybe I'm just thinking, outside the whole sciences. The third point, which also came to my mind when looking for any kind of leak in water, and the digging and adding smart sensors to see where are they. I'm just thinking about the easiest way to look if there is just to scan and measure the resistance of the earth in that areas, because I know what are they. I like when metal detection and all these kind of things that has to be done. Just go through the pipe. One worker will go through the sensor which measure the resistance of the earth, and by using transmitted reflected from the pipe, and then you get a measure about the resistance. The resistance will change if there is a humidity or not humidity. I mean, water has been leaked, because the water will change the resistance of the earth. So there are other things, not traditional, because these are traditional ways. We know all the flow meter and other kinds of measurements. People are working for this for tens of years now. So if we little bit far go back to physics, go back to another kind of technologies, maybe it will have some a breakthrough. And because this is a big trouble especially for municipality, they are looking for years to find some breakthrough to see under the ground what's going on. That's just an idea, so I'm not sure if it will work fine. There is no questions. All the work that I have heard, excellent. This collaboration between many groups, starting from the embedded device till the analytics on the top. Excellent. I like this kind of mix and merge kind of areas. Thank you very much.
Thanks for the questions, and now we can see who wants to take them. So just to summarize, we had the 3 questions about the smart pipes, especially gradual replacement after the current ones come out of life. The second one about radar measurements, and the third one more in material sciences, the resistance of the material. Can we maybe find out the material is worn out and will likely leak? Who would like to give it a shot?
Yeah, maybe I don't have the answer for the pipe obsolescence, but maybe some insights from Switzerland. For the irrigation networks, most of them were built in the late 70s or 80s, Okay, even some are older than that, and the pipes are gradually being replaced by new ones. And one of the questions that arise in that situation when you want to change the irrigation network, okay, you said that you have GIS and you know all the pipes, where they are, the dimensions, the type of pipes, is it a lead pipe or etc., etc. This might be true for a big city like Dubai or something like that, but in the case of the regions I know in Switzerland, the GIS is not so precise for the irrigation network, and this is a big problem because you have loops, you have new pipes that have been put in the ground someday, and someone knows about it, but maybe that someone is going to retire, and there are people there that have a lot of knowledge about the networks, but these are people. These okay, as long as they are there, as they are around, this is not a problem. But as soon as they retire, then you go into trouble. And this is the kind of situation that arises quite often in Switzerland, or at least in the valley where I come from. And concerning leakages, I was concerned a bit about leakages as well, because the network is quite old, and we were discussing leakages where they capture the water in Switzerland, and they say, okay, we have 40% leakage, and that's not a problem. And because in the end the water goes into the ground and it goes back into the cycle, in the natural cycle. The water is not treated. There is no except the fact that you get some water and you cannot use it directly, it goes back into the cycle. So they said, okay, 40% leakage is not a problem. Of course, if it starts leaking into the ground, and then you have problems with the land, and you have to do something. But otherwise, for irrigation, that was not a problem at all to have 40% leakage. But I assume the situation is quite different here, where you have to produce the water. So this was my insight on the first point. I don't know if it...
I am Iraqi origin, and in Baghdad, we have a lot of wars happened, and as you are right. I mean, these are manual, human-based, but they restructure the whole network again. They redraw on the GIS everything. This is matter of archiving, digital archiving. We cannot live now. We are in the 21st century. We cannot live on a paper or mind of people who are leaving the job or not leaving the job. We have to digitize by all means. I'm sure that even in Switzerland, better than in Iraq at least. So they are restructuring the whole thing, the whole network back. No humans is needed. You just go and scan under the network, and there are many devices for GIS company. They know them. They can find all the network, piping, which is for water, and even for electrical, because also electrical is under the ground. So they find them, and even for switch system, or the heavy water. So I think. I'm just saying that we need to have standards for the pipe to be replaced, like a group of standards. Just starting a group to look at how the pipe should look like from the end customer, the chemical, mechanical, and electrical, and ITC. So on this, we have a full range of the specs. That's sorry to interrupt your.
Maybe I can add something to that. Of course, what you say is very important. Maybe I wasn't clear. The idea is not that we are accepting the situation. We are, the people there are trying to map the system back into a GIS, and for water as well. There is a group that tried to standardize the water irrigation categories, and to put that in a data model, to have it on a country-wide data model that can be accessed from everywhere. But it takes time, even though it looks from the outside, it looks simple to say what's the data model for a water network. Okay, that looks very simple, but in reality it's more complex than that, and there are initiatives in Switzerland to go into that direction, but that takes time, and I think this is something that we need. The data, even for water, is very important, and I think this is the direction that we have to take.
So it looks like our panel, by a simple question, has already generated some interesting discussion. So we have more reactions on that one, and let's see if it will be the same or a different one.
I'll try to be short. To the use of radar, this has been done, and there are papers out there that have looked into this, and it's a method that has been explored. Then to the use of measuring the resistance, the humidity. Yes, there are things that you can do, and we also try to look into that. You know, what is the humidity of this place today, and we store it, and what is it tomorrow, and we store it. And in some places it might be fine. You know, if it does not rain so often, it's fine. When it rains often, then of course you have a kind of noise that comes in. But not only that, you also have the time that water propagates. This is not. It is not instantaneous, so it brings in some other issues. So they are good ideas, and there are aspects of these ideas that have already been investigated.
Yes, please.
I'm just making the most of my situation here and asking a question, if I may. We had in January an event with our colleagues, our friends from the UAE University, actually, on urban infrastructures concerning smart cities. And one element I have here, which I think we should address, is the relationship with the cities, with the utilities, with the authorities. In your opinion, how easy is it to work with such authorities? And also, I'm not sure if we have other representatives of public authorities in the room, but it would be also nice to see from their point of view what they will think. So, how easy is it to implement these new ideas at the level of the city?
Mario, I have an example from Florida with the authorities. They realized they had to get another plant of water treatment, and they discovered that it was cheaper to replace the toiletries of the city to more efficient toilets, because it would cost less than increasing the production of water. But that was a study done based on research, based on public partner. So there is a question that I was wondering is about efficiency, right? How do you improve efficiency in ag and home using recycling, for instance, of gray water from shower to toilet and etc. So there's a lot of opportunities of efficiency in agriculture, which is 70% of the consumption, and then 30% of the home and business.
So let's separate this into two questions. Thank you. First of all, the first one is how do you work with the authorities? How do you sense what they need? You want to take it?
Yeah. So for the authorities, they are also looking on what is best for them, how to control it, how to reduce wherever possible, and then if it comes to the point of leakage, also they are really after that one, because the water they are not selling, they have to pay from their pocket. So therefore, the leakage detection is utmost interest of them. And secondly, the quality of the water, to say nobody gets sick. And if you have a city of a few millions and you have the wrong water supplied, you have big problems, or the hospital has something to do with it. So therefore, they are, yes, looking into it. But on the other side, they are also quite conscious on not just jumping on each and every train. If we as a manufacturer coming to tell them this is what you need to do, which is good for us because we are selling that the instruments, they will really study it. Does it really help me to achieve my goals? Does it bring me forward? So therefore we have with DIVA some partnerships and some activities going on to say, okay, this is our solution for something, and then you have to check, and they will check thoroughly if it really helps or if it creates some other issues. So not easy to go with them, but the moment they see it is needed, then they will also put it into their recommendation and standards, but challenging to deal with them as they are authority, because they have to balance what to do.
And the next point would be on efficiency, and we will take maybe one statement, and then we have already another question piling up in the audience, so let's be quick, please.
About? What did
the efficiency?
I think it's beyond my expertise, so if there is another one.
I thought somebody wanted to give a statement on efficiency. So if that's not the case, then we go directly to the next question.
Okay, loud enough without the mic. So thanks a lot for very good. Before I start my question, I would really say that 5 minutes of your introduction, of course, does not show the pile of work that you people have been doing. So I can imagine that the projects that you've been involved in is a lot more than what we have seen. So my question is really very generic, and it is building upon your first question, and then of course there is this authority question which came afterwards. If we, these panelists who are sitting here, you people have been involved in these different activities which are directing towards the water management, if we just do some introspection here with the works that we have been doing, and if you look back with the type of work that the different panelists are doing, and if we say, are we, after this discussion, after looking into these solutions, if we go back, should we really change some of the things that we have had planned and worked? Was there any need, or is there any need to do it? Or my solution, for instance, is confined to a region. After this discussion, can I really change my plan? If yes, then was the money well spent? If there is a recommendation that needs to go to the authorities, then what type of collaboration models should be in place where we do the planning in the right time, for instance, where we know that, okay, we have to complement but not redo things which are either confined or which are done in a different way. You know what I mean? So this efficiency part of finding the solution for this problem domain. Thank you.
So that goes a bit into the process, huh? So how do we proceed to make those ideas happen? So who would like to answer?
So thanks for the question, and I might not be the right person of Andres to reply exactly, because we also, for the understanding, I'm not coming from the factory, so I'm not in the development of the products. We are more here in the country to say, okay, how we get the ready-made product into the ground, how to help the customers there. So therefore, on the R&D side, there is also from our company quite a big investment into looking what can we do better with the instrument, what can we improve on data connectivity, how to send data, how we get devices more reliable, so that if you put it into the ground, it can stay there for many years to go without checking them, without digging them out, without replacing them. So there is a lot of development has happened. In our devices, we have certain mechanism now in that you can do health check and verification without interrupting the process, so which is already helping the end user to say, I don't have to take that thing out, because taking a piece of pipe out of the ground is quite an effort, and most times will not be done if not really necessary. So there is already some kind of development done to be there more efficient, not to replace the devices every 5-10 years, or even take them out for calibration to say, is it still measuring correctly? So there I can tell you on the efficiency we have improved from a manufacturer point of view. Also the development which my colleagues here has put into place for sure will come at one point to the market, where also we as a company say, okay, this is really interesting topic, and we can really put it into place and scale it up to really put it into thousands of the meters. But I think from what I've heard, we are a little bit far away yet at the moment to get the research into our development and then into the product, into the market.
I'll just put a comment why I asked this question was because we were involved in one of the activities in Europe. So the whole idea was we did like months of work and a lot of efforts by the different consortium partners. And then I guess one of you also presented this light idea. We worked together with Osram So the idea was we involved communication partners, then we integrated the computing hardware, the communication hardware with the light, and then we once by accident met Osram, and we come up that there was this idea that they already had a product like that, where they had integrated the communication computation within the light, which was just to change the intensity of the light based on the presence of the object, for instance. So the whole idea was that we had spent huge amount of efforts without really looking into if there is something which could help us. So that's what I was referring to.
Yeah, maybe I could answer with a concrete use case. I'm working in a European project in the renewable energy and smart grid. So there are a lot of many expertise and many needs. So you have the system integrator, utility providers or energy companies, and then you have software engineering companies or software companies developing AI-based software for this kind of systems. And then you have also hardware providers providing devices for to implement or to deploy these smart devices that you will install in households, for example. And then finally you have communities, communes, cities, customers, prosumers, etc. So we are dealing with 4 families of stakeholders having completely different needs, different wishes, different problems. And for that, we are trying to set up for them kind of a marketplace platform where all these people can virtually sit together and define their agreements, contractual agreements, workflows, constraints, etc. That could be a solution for one use case, but it's not generic enough to be implemented for any other use cases.
Very quick.
Yeah, maybe in the same direction, I would say that the one thing which is important is the governance of the field. For instance, for water, we were contacted by a utility, which actually is part of a municipality, and they were having the problem of how do we scale in the future with the weather scenario of the future? Do we have to build more lakes for retention, etc., etc.? They wanted to know how to have a scientific response to that. How will it happen in the future? And the stakeholders here were clearly identified, and in the end, what we provided with different colleagues from hydraulics, from meteorology, from different institutes, and computer scientists as well, hardware engineers, was a kind of generic tool for communes to build something for the future, to know how much they need water in the future. But in the end, we don't even know if the answer was correct or not. So it's a bit the same.
So I fear we are slowly coming to the end of the first round of the panel. I have a lot of questions written down that I wanted to ask the panelists myself. But let's have one last round because we were mentioning, and for me it's quite natural to talk about this edge cloud technology, right? So for me the term is quite natural. But many of you may ask, what is it? Why do we need it in this context? Because we have talked about increasing the number of measurement points. So is it any useful? What is it at all? And concerning the energy efficiency, we have heard that we can do energy harvesting for measuring and communication, but then we also need to cover the computation, which is a completely different game. So I would like, as a final set of questions, go into this area. Maybe there are some remarks or explanations concerning edge cloud technology and energy efficiency of the compute part.
Edge to cloud technology, it's kind of a response or an answer to a problem, which is, this centralized vision. So we have IoT devices in water management or in any other topics, collecting data and then sending everything to the cloud to be processed. This is something which is out of date. It's doomed to fail because we have a huge quantity of data because of privacy and security aspects, etc. So we need to have something. We need to migrate the processing from the cloud close to the data, and this is the edge device. And maybe if I have prepared a video. Can we use it? That answer in few minutes the question. So it's this one, yes. So it will answer the question and it will give a use case which is not water management but could be extended to water management. The project is called Medina. The deluge of data collected by thousands of sensors deployed at a city scale need more intelligence to understand what's happening, take quick decisions, and very importantly, evolve over time. From a technology perspective, we need to bring together key technologies such as artificial intelligence, machine learning, Internet of Things, edge and cloud computing in a way that does not lock the users into a specific commercially controlled set of services or technologies. All this is complex to put in place. Medina addresses these problems by delivering a solution that can be run as a service by our industrial partner 6 Square.
There is an explosion of data happening around the world, and conventional wisdom so far has been to push all the data to the cloud for processing. Well, that's just not working. Even with 5G deployed everywhere, there is just too much data. It's the wrong approach. Instead, we need to do it the other way around, where we process the data like video and audio streams closer to their source. That is what is known as edge computing. On top of addressing the issue of the amount of data processed, the edge computing approach also brings additional key advantages such as avoiding privacy intrusion issues because the video streams are not going over the wide area network. Second, no more round trips to the cloud and back, which takes time, and it reduces network and storage costs. A concrete example of edge computing, and one we've worked on in a tight collaboration with the Geneva Business School, is dynamic street lighting on busy streets, roads, and highways. The idea is to adjust the level of lighting based on the density of traffic. The logic behind that is the more traffic there is, the more lighting we need to provide to keep the street safe for all of its users. To do that, we use a video camera connected to an edge device. The edge device runs a machine learning application which categorizes each vehicle and counts them anonymously. This information is then used to decide in real time if the street lights of the segment of road must be increased, reduced, or left alone. All this logic is done locally without the need for a round trip to the cloud and without any intrusion in the privacy sphere of citizens. However, if the machine learning application cannot correctly identify a vehicle, then the cloud is notified with the images that has caused difficulties with. Eventually, this triggers a new learning cycle, resulting in a new version of the machine learning application, which gets pushed back to the edge devices.
Concretely speaking, Medina aims to reduce the total cost of ownership of edge-to-cloud modern IoT application by providing an IT ecosystem composed of a set of services used to develop, deploy, and monitor this kind of applications in a seamless way. Here, edge-to-cloud modern IoT applications means self-adaptive machine learning-based IoT applications deployed on edge-to-cloud infrastructure where the edge intelligence is improved by the cloud. The edge device learns from the cloud and adapts its intelligence to match its local context. This ping-pong game between the cloud and the edge can be represented by a closed feedback loop. From a software engineering perspective, Medina will lead to a new paradigm of continuous integration software applied to these edge-to-cloud modern IoT applications.
we see that edge computing is more and more used in conjunction with machine learning
yeah.
applications.
So you see here just one use case for edge to cloud, but it could be extended to many other use cases in smart grid, renewable energy, noise management, smart city, and even also, of course, water management and smart agriculture.
So perhaps we need to move closer to the edge, but then what about the energy efficiency and the harvesting? Would this work? How much have you done experiments with small chips that can do some computation on very small amounts of harvested energy?
Yes, we try to do as much as possible. Locally, one cannot do everything locally because sometimes you need data on the whole chain to be able to make a decision. And for that, you will have to go back to the main machine. But the decisions that can be done locally will be done. And for that, we are looking into low power processors. We already use processors that need very small amount of energy. We are going to move into in the next generation, depending on the kind of sensors that we have, of course, we're going to move to even better processors. In terms of energy, yes, we can run today a small device with 16 CPUs. We can let it do certain measurements without problem with the energy that we harvest. And after, we just switch it off.
That's a nice final comment. So we have a lot of points that we can act on. Due to the time having progressed, we will conclude the panel now and our roundtable discussion. I am thanking again all the 4 panelists that are here. I'm sure they will also remain available in the break. We are entering a break now in case you have additional questions. Thank you very much.
Ladies and gentlemen, we will have our final panel of the day at 4:15. This is 1:15 Swiss time about ICT resilience for smart cities applied to mobility and other fields. So stay tuned and we'll reconvene in half an hour. Thank you very much. What's more, if you want tea, coffee, you can just go to the bar. Thank you.
Now I think I meet Vanessa. Yes. Sometimes here, depending on the application.
Thank you.
Yes.
More data just to avoid all the activities.
Hello, does that work? So, welcome back to the second panel, which is on resilience in ICT-supported mobility and logistics. It will be an interesting panel, as already discussed, that we have panelists from divergent fields. So I'll be introducing panelists briefly and calling them out on the stage. So the first panelist that I'll be calling out is Professor Dr. Ruth Schmidt. She is the head of education of School of Engineering, and she is a researcher, designer, and a facilitator. Her background is in business administration. She has 20 years of experience in applied research, and she's recently working on creating local acceptance for renewable energy in different energy sources. So thanks a lot. Our second panelist is Professor Laila Ismail. She's an associate professor in College of IT, UAE University. She is the founder and director of Induce Lab, and she has been working in different research areas, also worked with industry, Sun Microsystems, and has been working with artificial intelligence area. She has won a bunch of research funding. So Professor Laila Ismail, thanks a lot for joining. And I have a very important. So our third panelist is Professor Qasim Nasser from University of Sharjah, who is currently working as a professor at University of Sharjah. He has been working as chairman of Scientific Publication Unit. He was the chairman of Electrical and Computer Engineering Department. He has been coordinator of the Open UAE Research Group. He has also worked in the industry, working with Nortel and other industry. He has taught around the world at Ottawa, Helsinki University. So thanks a lot to all of you. We'll start with the panel. As the format of the panel is pretty much the same as we have seen in the previous panel. So we'll start with a brief introduction where the panelists will introduce their work in brief 5 minutes, and then we'll start the discussion. We'll try to make it as interactive, as interesting as possible. Your participation is needed. So back to you people. I don't know, we start with Ms. Professor.
Women first, yeah.
Yeah.
Thank you very much. Thank you, Dr. Manzoor, for the introduction. I'm actually working. My main field of research is on cloud computing, and this is actually where I started the lab in 2009. The lab in 2009 it was about actually grid and cloud computing, and how to use the cloud computing for smart cities applications before smart cities become really emerging topic after that. But the vision was at that time is how to use the cloud computing and how to implement what I called at that time the OS for the cloud computing, the operating system of the cloud. Usually the operating system is a one computer is in a laptop or on a server, but the vision that I have at that time is to build an operating system for a cloud data center, and it was back in 2000, between 2007 2009, and now cloud computing is actually deployed at a large scale globally, and it is very, very important and critical in smart cities. So this is, and then today we are, the lab is about the Intelligent Distributed Computing and System lab, in which we are working on applications which are distributed, and then which are intelligent, but also it also get benefits from intelligent enabled system using artificial intelligence, and this is why I have in my main research field the artificial intelligence keyword. Then in smart cities applications are our main focus, and in particular smart healthcare and smart transportation, and using the edge cloud computing as a computing information communication technology support. And for security, and of course we will talk about security, and that is essential element of any distributed computing system, and in smart cities in particular, and we'll see how it's very important as well for mobility in the discussion. Then we are also working on a blockchain as enabler. So here I'm not, for the sake of time, I'm not presenting all our projects that we are working on in Distributed System Lab, but I'm going to focus on the ones which are in relationship with the panel topics here about mobility. So basically the idea is that we have smart cities with the era of digitalization and the introduction of smart cities. Then we have opportunities to have applications that is enabled by the infrastructure that we have. If you can see that we have the infrastructure here, which means of the cloud, and then we have communication infrastructure. If you can see the vehicles, between the vehicle and the edge, between the edge and the cloud, and that ICT that we are going to discuss this supporting technology, and then how this can be it can be useful for a smart cities application. So while we have these smart transportation systems and the smart intelligent transportation applications, is that we need to have comfortable travel experience for the drivers and users to improve safety, to improve efficiency in terms of time and cost, and sustainability and energy saving. So these are our main problems that we are focusing on to solve. In our lab, with my research team, we are focusing on how to use AI-enabled energy service level agreement aware execution of intelligent transportation system application using the edge cloud computing technology. And then, as you can see here, one of the experiments that are taking place in the lab is how to use AI, and in particular we have some experiments with the meta-heuristics algorithm in order to save energy, but at the same time take care of the quality of services for the applications, and at the same time respect the constraints of the application that have sometimes like very strict constraints. And so we are using also blockchain, and then developing protocols within the blockchain that will be aligned with the nature of these particular applications, which are of type transportation or of type smart healthcare in another topic as well. So thank you very much.
Thanks a lot.
I'll pass.
Yes, please go ahead.
Okay. So can we switch to maybe? Is it? Can you hear me now? Okay. May I switch to the? So it seems not to be there. So I'll just introduce myself without the slide. Yeah, my name is Ruth Schmidt. I'm from the University of Applied Sciences of Northwestern Switzerland. I work at the School of Engineering, which is said that I also am responsible for the programs of teaching that we have. But I'm here with my hat on that I do in research, which is I am trained in business administration, and I always had a focus in my research in sustainability issues and how you get the stakeholders on board for resolving complex problems. My colleagues in the first panel mentioned that there is not only a technical side to some issues, which may be related to smart cities, but also to other questions. And whenever you have to deal with complex problems, at some point you ask yourself, well, how can we get the stakeholders on board? I have quite some experience with energy infrastructures. I started with projects abroad where I asked myself, okay, there is always this idea that you can manage stakeholders, but what do you do if you have an extremely complex project with like 250 stakeholders coming in, leaving? It's a pretty dynamic environment, and these days the theory didn't have to say much about this. So I studied the cases intensely, always with that question, well, what do you do if you can't manage stakeholders in a classical sense? What else is it? I started with energy infrastructure projects abroad, but in the last few years I did many energy projects in Switzerland, and it was basically the same underlying dynamics. So it is really the question, how do you take them on board? How do you develop strategies with your stakeholders rather than kind of for the stakeholders? And I think we just started with the technical side, which is absolutely relevant. But the companies that came to work with me and my team usually said, hey, there is a lot of resistance. What can we do to overcome it? Now, maybe Switzerland is a special case because it's pretty densely populated. It's really, bottom up. So the communities have a lot to say, so you cannot impose any solutions on them. We have very complex administrative, political processes, planning processes, technical processes, and eventually it's really how do you coordinate all those so that you can take the most out of it. Now, when I started, it was more like a risk minimizing approach, saying, okay, how can we deal with the stakeholders so that they don't make any trouble? I think that has changed. The perspective on stakeholders has become more strategic in a sense. How can we involve them? And by now, I think with all the grand challenges that we have nowadays, like the energy transition, we have to go into a transformation. And I think then there is more to stakeholders than omitting trouble. It's really, how can you develop, how do you identify the relevant problems? How do you involve them in problem solving? And who is going to participate on the result side. And this is something that I think is extremely relevant as soon as you start to talk about complex problems, like we saw the SDG goals before. So you always have a lot of interests combined, and that's basically my interest in how can you do that together. It's a strategic value creation perspective. So I don't know, I hope it's not too theoretical what I said, but I have a lot of intense experience in the field and lots of also field work to hear the original stories from the people.
Which we would like to know in the discussion. So please, Professor.
I don't know if there are slides or...
I don't know. We can try.
I don't know because Manar she is... if not, no problems, I can talk. Okay, no problems. Okay. Myself, Prof. Qasim, I think we already talked previously. I just want to mention that I will not talk about myself because there is a long history of CV, so I will try my own best to talk about university work, what I did here, because I switched from academia to industry, back to academia, back to industry, back to academia. So there are switching on and off. In university, we have one like big category for research and another one for teaching. So we have full structure for research and full structure for academia. And when you talk about structure, it's institutes and research groups. And research groups belong to those centers. That's the idea, how they are structured. Myself, I am coordinator with my colleague, Dr. Minash, she just came back. We are coordinating in a group called Open UAE. Maybe the name seems to you strange to you. Really, it's an UAE initiative. It's to use open source. So we have coders. We believe in using open source to code. We are generating coders that are able to have their own code or develop or add to already existed codes on the net. So we are generally OSS, open source field. And when you talk about open source, you can imagine that how many areas that you can cover in open source. Just go to GitHub and you see the areas that is being covered. But we didn't cover all the areas. We cover the areas that we can do. We have 4 or 5 members. It's just one we added lately. We are 4 from computer science, computer engineering. I was in electrical. So we have 3 categories. So we did a work in different areas in that group. AI, blockchain, and so on and so forth. So any open source for RF application, drone detection, drone jamming, and in the area of RPA, because I was happy that I heard from Prof. Schiblinger about the web scraping. We name it differently. We call it RPA, which is robotics process automation. We do more than what's just web scraping. So this is a complete open source. Just we have a team doing RPA. We have a team doing AI in all fields of applications, in medical, cancer detection, breast cancer detection, and also using genomes and the other dentistry fields, so many other areas we have, I don't know how many researchers we have plenty, I cannot count them, but my partner, maybe she has a good number, maybe more than 20 or 30 researchers in the lab. And also we have collaboration with the industry. Here we have a very good collaboration with GCAA, which is a global, if I'm not mistaken, aviation authority, which is govern the whole aviation in the country, and they open a center of excellence for aviation in the university. We are managing it. So we have a plenty of different areas of work. Maybe the interesting here that we have communication areas. We have also IT areas, which are maybe could fit in the topic of ICT resilience, because when you talk about resilience, you need reliability, flexibility, you need quality of service. We have just finalized a PhD degree in one of our students. His work is just quality of service for IoT. So because IoT is now used for measurement, for control, for monitoring. So in this case, what are the quality, how we can measure the quality? So it's from managerial part, but again, we can manage managerial with the engineering to do this such kind of work. I wish that I can talk more, but I know the time is limited and it's very late. So let us make maybe, if you depends on questions and answers, we can have more discussions. Thank you
so very much, Professor. So I had a set of questions which I just kept down, so which means I'm not going to ask them, because after listening to the introduction, I have some more interesting questions. So I have been involved in similar activities, and whenever I would start with my talk somewhere, I would really say that there are some fancy buzzwords that are mostly misused, like autonomous driving, smart systems, all those things. So, and sometimes I would even call them, they're abused, in fact, because the way we are putting it together. So my question to the panelists is that when we are talking about the future transportation system, we can call it smart transportation systems, and we say that one of the biggest step that we want to achieve is the digitization of the infrastructure, in, so to say, in that case. And the digitization is, as you said, in Switzerland, there may be a lot of a lot of bureaucratic things that you need to undergo if you need to do the digitization. So we did one digitization of one of the roads in Berlin. I remember that technically it took us a few weeks maybe, but in order to really realize it, it took us months, maybe a year more than that. Because from where originally I come, we are happy to show our faces to the camera, but their privacy becomes a big issue. You need to really tackle that. But we did not have right stakeholder in our discussion. So if we have the technical solution for the future transportation, but you cannot implement it, so can you share your experiences of Switzerland, for instance, with us, bringing in the right stakeholders for the digitization and smart transportation system in that case?
Well, maybe I can give kind of, to start with, a more general answer to that. Yeah. I think often we have a technological solution in place, and then we think of, okay, how do we sell it to the ones that should use it? And I mean, we had some, I think, well, now let me say first this. What do we do if we just go this approach? You could say, well, you have to start somewhere. What should you talk about if you don't have at least some idea what you want to do, right? Yes. So I would say that's a technical approach. So you have to have something tangible, and then you start going out to the stakeholders selling it. Now, I will propose a completely different thing. And I mean, maybe we can build upon that idea that you have a lab and you include stakeholders, but you also had a procedure, Joseph, that you proposed before. Maybe we can put that upside down, or at least enlarge it, and maybe that would be a more concrete way to talk about it. But I think what would we miss out if we do not include them? I think, well, first of all, they would participate in problem definition, but also solutions. I think stakeholders, they can show their challenges, and you always need to understand those projects in their local context. I mean, Berlin is a total different story than if you do something in Zurich, but still you have some common underlying dynamics. But what I think, what is more often the case that I saw in my project is, often people don't know a lot. Why would they have to save water? Why does it make sense to introduce some smart applications? And I think increasingly the common know-how on those topics isn't around. People don't have the expert knowledge. And I think if you include the stakeholder in all the project development, you also have the chance to build up a common understanding of the issues that you want to resolve. Of course, maybe there is some negotiation there, maybe you won't put through the ideal solution, but I think this learning opportunity is often missed. And you can, I don't know, I mean, with all the fake news around, all the, I'd say, non-expert knowledge that takes off, I think this is an important part and that's why I think we should get more clever in our strategies of how we develop innovation, about the process. How do we do it? It's a lot of work, including stakeholders. So, and there needs to be know-how how to do it, but I think it's rewarding because it's an upfront investment, but then things go smoother at the end. And I think it's a more, when people participate in the solutions, you can tap also on their knowledge, and you have a value creation that is shared. And I think, sounds theoretical, but I strongly believe in that from what I've seen from my field work.
Thank you so much. I'll complement whatever I said and take this question to you. So from what I understood from here, that there is definitely a paradigm shift with a new ecosystem, especially when we are talking about the future transportation. It's no more OEM specific only. It's the authorities, ICT providers, communication providers. This is the new ecosystem you're talking about. If, Professor Laila, if I bring this question to you, that with this new envisioned ecosystem, You are working, doing the research in this specific region, and you have now new players in the ecosystem. With your technical solutions of your lab, looking into the vision of the future transportation system, what do you think, how can we realize the objectives or vision of future transportation system specific to this region?
Yeah, this is a great question, and also I agree with Professor Ruth. What she said is that we should not work in isolate components, distributed systems, but it should be cooperative system and cooperative component. And what I see is that, so far we are all working in isolation, and we have to collaborate more. And this is why what she said, Professor Ruth, is really fundamental and critical. So bringing all the stakeholders together, the users. So what the user needs, the user have needs. The users of the smart cities applications or the applications that we want to put in place, this digital ecosystem. So the user have needs, and but they are just they speak up about their needs, but we see also there should be someone who listens to their needs, who are the labs and the researchers and the universities and the industries. There should be collaboration between the industries, the social context, the the people who will use the applications, and they are the main stakeholders, our customers, the end customers, you can say, and then the others. So when you see the opportunities for applications, like I mentioned some of them, they want to enjoy comfortable and pleasant travel experience, right? And we can see they are annoyed and then even desperate sometimes to have this enjoyable travel experience. So application like infotainment, interactive gaming while they are in the car, even online learning while they are in the move, ride sharing, mobility, traffic flow management. How much will be their life easy if the traffic is the flow of traffic is so easy, and we can get to job easily, or we can get to the hospital quickly because there are patients in the ambulances that they want to arrive very quickly. So to a medical center. So traffic flow management, accident prevention. I noted some of the applications that are critical for safety. Autonomous driving. We introduced autonomous driving because of many reasons, but one of the main reasons is that I read there is by Stanford law, based on Stanford Law School report. There is the accidents, the car crashes, 90 to 99% are caused by human errors and human behaviors. So that was a shocking number for me to see that. So which means autonomous driving is also would contribute to reduce the mortality on the road. Other things that real-time navigation, traffic congestion information, and so on. So also very, very important as well, objective goal is the fuel saving, energy savings, because cars actually they emit carbon, so it's the carbon, the house gases, carbon emissions. And then if we have applications that allow for, a flow, traffic management, which is efficient, and then also ride sharing, this will allow also to reduce the emission of house gases, house gas carbon emissions. So which actually help to in sustainable cities, and then to have a green environment. So, which is one of the sustainable goals that we have talked about this morning. So getting all the stakeholders together is very important. The users who are in need, the lab, and then the ecosystem that we have from ICT to software to artificial intelligence and other stakeholders Professor Ross talked about is very important.
Thank you, Professor. So I'll really take the same question to you, Professor. Since you have worked in industry, you're working in this region, we are talking about the new ecosystem. Could you share, like, how would the future transportation system and the envisioned ecosystem, especially with your experience, look like in the region? Yeah, it's working.
Thank you. Let me be frank with you. I mean, any implementation of any system, you have to own two ways. Either by pressure, by governmental law, khalas, yeah, you have to do it, then everything will be done. Or the problem comes from the customer. If the problem is not coming from the customer, he will make a lot of barriers. He will kill the project. And we have many examples. We did one very good project with DESC. I don't know if you're familiar, Dubai Electronic Security Center. This center, they came us with an idea. They want this. They want IoT test bed. That means you take an IoT, test the security of these IoTs. Different IoTs existed in the market. They are running after us, not we are running after them, because at the end they want the product they can show. If we tell them that we will do it to you, there are a lot of barriers. And this happened, same thing. We are going, to propose smart city or smart kind of communication, kind of encryption, and no one will go. Maybe it will go theoretically, we can publish papers, but at the end, when you go to the implement, they will kill it. So I believe there are two ways, depends on the nature of the community that you are working for. If the nature of the community can be coming by pressure, by force, yes. And the nature of the community, like in the Europe, then maybe you have different kind of restrictions that you have that come from the customer. The third and the last one is to do it by example. Because if you are not doing it by example, you should wait for 2-3 years to have a project, maybe it's not run completely, and then they will say, oh, what is this? I mean, we spend a lot of money for incomplete project. So I believe did it by example. Make a small itemized project. Show them the benefits, so they will be convinced. Not writing papers. The papers are excellent for us in academia, but when you go to the community, they want to see something real. They want to run it, see it. Oh, they're convinced that it's that you can do it. And the other points I'm just trying to remember, because I'm coming from two different areas. The standards followed by the industry is different from the standard of the academia. I mean, in the academia, we don't have time limits. We can do it in 1 year or 6 months, while in the industry, they cannot. They have budget. They have to finish in 1 year. You have to have milestones, strict milestone to finish. And even the standard, the way that you are doing the project, you need to know their standard, the way of reporting, the way of doing that. So all these are combined together. So I believe having industrial researcher with you, and maybe I think mentioned by Prof, that to have from the customer, from the, it will be a great success. Sorry to take more time.
Thank you so very much. I'll open the floor for the questions from the audiences. We've already listened to great. Yeah, there is a question.
Thank you to all the panelists for your expertise. Following up on the point that Professor Qasim brought up, where the customers would kill the potential of a project coming to life, I think a great or one of the biggest contributors to this killing is the fear coming from the customer, because the customers are tech illiterate. They don't understand technology, especially if we start to incorporate autonomous technology such as AI and whatnot. So my idea is to reduce this reduce the need for turning systems or making systems autonomous. One of the ideas that I have in mind is why do we talk about autonomous driving as in autonomous driving cars? Why do we not talk about, such as in Switzerland, most or a large portion of the transportation system in Switzerland is governed by trains and buses, not by cars. So why don't we talk about autonomous trains, which can be safely autonomized and taking human factor out of it safely without introducing such fear in the customer from such high complexity in autonomous driving cars. Thank you.
Anybody wants to take Switzerland في area?
Yeah.
Otherwise, I can.
I will take the answer. Yeah, thank you very much for the great question. And actually, this also came to my mind, is that it's not only autonomous cars, it's autonomous transportation. I think we should have autonomous buses, autonomous trains. And then one, I don't know in which country there is autonomous train, but I'm not sure in experiments, as experimental. But yes, you are absolutely right, because public transportation, and if you have drivers and we have human error, it's catastrophic. So absolutely, we need, when we talk about autonomous cars, actually it's not only cars, but all kinds of mobile vehicles, I can say vehicles in general. So it could be any kind of vehicles.
Just to complement what she said and respond to you was, so usually the cars version that we talk about is the most complex one. The trains are mostly autonomous, like you sit in it and that's it. 80% of the times your flights are autonomously, flown. And then of course, the drones do not have the streets, you know what I mean? So the ones which are the most complex are the most challenging. That's why you listen to this more often. So this would be my complementary remark to that. So thanks a lot. Yeah.
I just want to add, I think, Mohammed, coming from the simplicity, we cannot get rid of people. I mean, the technology should assist people, to have a better life. But remove them without the driver, without work, then there will be a lot of hesitation here. So we as engineer researchers, we have to think about the technology. How can we assist driving? ADAS. I'm sure people working in the transportation, ADAS is automatic, I think, driving assisting system, something like that. So this is where we have to use the industry, like what the project has been mentioned by water leak detection. The human cannot do it. He cannot dig and see where is the. So these are the places where we have to really invest a lot, and also reducing the energy needed, etc. Where the people they cannot be contribute, removing the human at all, it will be a lot of hesitation, and the research will be coming at the end one day. But we have to look at the, as I think Prof mentioned, awareness. We have to also technology awareness for people, so they believe in technology that they can solve their own problems rather than remove them. And let me tell you one story, which is funny. For me, it's funny. There is a company. I don't want to mention the name of company. They make a contract. They tried to make a contract with the bank, and also I will not mention the bank. And they told them, I can automate all your processes, but what I will do, the percentage of the people that you remove them from the work, give me 50% of their salaries. So for example, if you get rid of like 70 employees, for example, then you get 50% of their salaries. Look at the mentality of the company, how they want. It's a process automation. You just remove a lot of from HR, from accounting, all this work. So look how when he comes to the decision maker, what he will do is he will really trying to remove, the employee who served the company for a long, long time, and now it comes one day because the technology they want to replace it. Yes, it's faster, quicker, and more exact. So anyways, they did this kind of contract, and they get read a lot of people. Here where awareness coming. The people who worked in this area of where really can be converted to human, to non-human or robots. In this case, they have the new generation, like mine, you know, my sons, my daughters, your son, your daughters. They have to be educated in a way, you know, the system of education has to be a little bit changed, where you are preparing them for somewhere else like this could happen. Do you have any comment extra?
Well, maybe I would just play the ball back to the audience, because we talk about different stakeholders. And I mean, you mentioned some examples too, and I was just going to play the ball back and say, well, what do you think? What roles would the different stakeholder categories have to improve things? What would you expect from, I don't know, universities? I have a pretty clear idea about that, but what would you expect from authorities? What would you expect from the communities? What could be their role? So I'm just going to ask back.
Any comment?
Yes.
Two points I'd like to mention. First is a continuation of answering my own question. Where instead of completely getting rid of humans, we would reduce our dependency on them. So as we spoke on autonomous train systems, more people who travel on train now don't have to drive. Less cars on the road means less accidents on the road. This also allows for specialized or specializing the use of roads for ambulances and emergency vehicles. The second point is answering your question directly. I think people have this concept where in autonomous transportation that software is going to completely take over the future of digitized transportation, when in reality we're actually talking about augmenting the experience, driving experience and transportation experience. So I think making it clear that it is not an overtaking of their control, because people feel lack of control. They don't want to lose control over what they possess. Just making or clarifying to the people that we are augmenting and we're not taking over the control, I think, is a huge leap in educating people correctly.
Yes. Can I take this? Thank you very much for this comments and for the question. So I agree, completely agree. Is that awareness?
It's working. It's working.
So awareness of that this application will not completely take over people is very important, and is actually to help them and to increase and to improve the safety. But I would like to precise is that for the intelligent transportation system application, autonomous driving is only one application of that, and then we have, as I mentioned, many applications such as to improve the safety, such as accident prevention. We have, for example, through image processing, patterns recognition of what's going around the environment, and the context awareness, like through different AI technique, artificial intelligence techniques. So this is an addition. Actually, these are advantages that are beneficial for the users, and not to take over the. So autonomous driving is only one aspect of mobility, but we have like a lot of applications which are not taking in the contrary, which are not taking the human role. In the contrary, they are just improving safety and efficiency and cost.
Professor has a question, and after Professor's question, we are going to play a video by Swiss Transit Lab before the next set of questions. Yes, please.
Thank you. Well, the planes are controlled by computers. right? I think someone mentioned that. The food that we eat is controlled by computers. And there are many other things that are really controlled by computers today. But it seems to be a problem with cars. Could it be that it is not only a stakeholder problem, but also a problem of how things are portrayed and passed over? You know, because we can blow up a problem that is not really a problem to the point that we all fear. You know, we don't want to take a car because it's going to make an accident. What about the food?
Do you want to take it? Or?
Yeah, I mean, that's actually, thank you for the inputs. I mean, I wanted to just kind of create a change in perspective. And, you know, I mean, talking about our own role, I think we're experts. We always say, you know, have a straightforward way of dealing with problems, but, you know, maybe understanding better from the perspective of the stakeholders. I mean, it's pretty common in IT that you do include your customers in the development of some products, but if you have more far-going problems, you will have to not only include the customers or the users, but other stakeholders as well. And I think key to that is really changing perspective and understand their fears and things, because it could end up that it's just not so much of a problem if they understand what it is all about. And if it's a problem, you probably will get some real helpful hooks to improve. And I think that is, to me, essential to the innovation process, to let them participate, and you will learn a lot.
Yeah, thank you very much. Really, that's the laws also. There is no laws. Who will, if one get killed by an autonomous car, who will be handled? Who will be getting to the court, and what kind of court? So all this, it's a huge story. That to having to change the laws in order to to examine the robots. So who is the robot creator, a robot manufacturer? So also we have, I think as you mentioned, maybe you are creating another problems. So that's why anything related to humans, we have to be very, very, very careful and implement it in real life.
Very good. Thank you. Any comment from you? No? So can we play that video before we go to the next set of questions? We had this video of Swiss Transit Lab. That's the video. Meanwhile, we comment on what you said. Let me just complement that. So sometimes we say that ignorance is blessing, since we literally, and it's about autonomous cars, since it's my area, I literally. So there is this one level of autonomous vehicles where a driver has to sit behind the wheel, but should be ready to take the control whenever needed. And then that's the level just before the fully autonomous car where you don't have the driver control. So the idea here is we want to reduce the accidents, but you are going to train the driver on how to smoothly take the control. Because as soon as it alarms you, are you really ready to take the control? You will just get puzzled and then do another accident, you know what I mean? So we have to go through many experiments.
That one?
On regards to how to frame the problem to get the right solution, I did a pioneer carpool social network 10 years ago. BlaBlaCar is in Switzerland. And I think one of the indexes reduction of accidents, but that's one. And another thing is how do you implement features for sociability? In an example that's simple, you took a plane, 5 hours, you were sitting next to somebody that you don't know, and maybe in that plane there was somebody that you could have had 5 hours conversation with and would have be as valuable as this conference. Why don't we have the social networks with AI match the people sitting next to us to make most use of our transit times? Because what is the optimization of experience? Is return over attention. So why are we automating so much mobility? Because sitting behind the steering wheel idle in alert mode is not the best return over attention for a human being. Okay, understood that. We shift some of that cognitive load to the machine, but we haven't solved the problem. And there's a lame duck sitting, which is how to improve in Swiss trains, in the subway systems, in airplanes, the sociability of the commute experience. And BlaBlaCar is named BlaBla because it was aimed for that goal. But I feel like social networks in 2005 were meant to make dating easier. Today, it has still failed on their mission. Therefore, you see the number of divorces in Switzerland, 50%. You see a lot of the countries getting there. So I believe we got to humanize the objective and not put technology first. Technology is at service of higher return over human attention. And what is a higher return of human attention? It's got philosophical problems, sociological problems, ethical problems, because this time that we're freeing from autonomy, we've already automated airplanes, for instance. 500 people sitting on Airbus 380. What are they doing on the 30? I took 15 hours from Brazil here, sitting next to somebody I have no clue. What a bad use of 15 hours. If there was somebody that was coming to the expos that could sit next to me even for 15 hours, talk about what we expect from Expo, what we studied about Expo. So it's such a low-hanging fruit at the moment. It's obvious that Europe is number one at that because BlaBlaCar is in Europe and because you got public transport. But still, public transport is a bad experience, including in Europe, because the social aspect, we have already technology to solve this, but
such a good perspective. I would really bring it here. So I love that. Please.
Yeah, thank you very much. Really, very good, very good. It's outside the engineering, anyways. You are talking about completely another kind of line of work, sociology, and psychology, and all this aspect. Very good to add to what we said. But again, I just have one perspective, because I am old. The new generations are maybe different from me. When I go and try to chat with the chat box or with this robot, I don't like it myself. I like to want to talk to. Nevertheless, my son, he like it because he want to talk, me differently. So that's why I think the university has to change as well, to add whatever you said, for the people to be familiar with the, with the robot, that even robots, the machine again, maybe I refuse it, you refuse it, depends on the kind of people. But if you teach them during the study, they are familiar with, they are chatting with unknown people, but they understand you quickly. What is your, what's your thoughts? Whatever you like. You like soccer, you like basketball. They will talk in different areas, politics. And if you like movies, they will give you like small short movies. So I like the idea. But completely is out in engineering, but the engineers has to think, carefully. They might, brought up system that, bridge this gap between the sociology, psychology, and the engineering aspect. Thank you very much. Very good point. I like it myself. Please, you want to talk?
Go ahead. Thank you. Yes, what I understand from your question is, why don't we use AI in order to, I wouldn't say to match people. I mean, where they are taking public transportation, right? So matching people in different, converging interest. Like sports or education or any other thing. So what I say is to use the AI for doing that, and yes, I mean I think it's a very good idea, and I liked it, and I think it's a new approach to social media, because now you open Facebook, but you don't know the people there. You're just your friends. Then you know your friends. But why not using AI for an intelligent social media? I can say for a smart social media in a smart city. So very nice idea. Thank you.
Sorry, it just came to my mind. You worked with blah blah, or you have some idea. Why did it? What went wrong with it? Because it is.
Well, lessons learned. Timing is of the essence. I did it in 2010. After doing 2 years masters in Italy with no car, back in Sao Paulo with 7 million cars, 2 cars in my garage, going 10 kilometers an hour. 90% of the cars are with one person in my city. You could walk at 10 kilometers an hour. So this is wrong. How do we matchmake? In my city, my friend got killed doing hitchhiking. So there's a serious problem of hitchhiking, and public transport is terrible. So I said, this is a social problem. How do we make the transport with friends? Because sometimes I was going to my work, my neighbor was going to the same building, leaving the same, were 2 cars. How could we give this information? So back in 2010, I said, I looked around the world, what was the best solution? The best solution was before BlaBlaCar, which was German, yeah. I don't speak German. And there was
Mitfahrgelegenheit,
which BlaBlaCar bought. And there was the roll-up strategy in Europe. And the best technology solution was called Zimride, that pivoted into... I phoned Mr. Zimmerman, said, John, do you want to come to Brazil? I'll help you. And he says, no, we're busy pivoting. I said, okay, so I'll copycat. We pivoted a bulletin board system into a social network to give the information. Not only this person is going there, but he's your friend from university. He's a friend of your friend. He's from your university. He's in such a group on your LinkedIn account. So give you some social proof to reduce the security risk and make that matching, right? Early days, there was no AI. But in 2011 and 12, you must remember how many pushbacks Uber got. And we got pushbacks, and people, I was dealing with oil companies. I was a couple of cartels that kill people. And I was personally being threatened to cease and desist. And I didn't have the backing which these companies had. Uber fought the legal battle with lots of money, 5,000 cities, and they got to be... Zimride pivoted, is called now Lyft, and IPO'd at $23 billion. It's a good idea, but they still haven't solved this problem. So this was a problem that this timing hadn't come. So I'd say in 2010, the technology, the society wasn't. And why was carpooling more prevalent in Europe than in Americas, because America is more dangerous than Europe. So therefore, you would be more trust. It wasn't the solution; it was about the society was more.
Also, the personalization. Some people are very religious about personalization of their vehicle. They don't want to do the car ride sharing or something like this. So
I just want to add one point, because what you are talking about is already existed in intelligence. I mean, most of the security people or Ministry of Interior and Ministry of Defense, they have all this information that you are mentioning, and there are big softwares that will link you with all your network with a nice graphical approach. Even there are even open source for that. It's called, I think, if I'm NIST or I think NIST. I can copy you that. But this kind is existed, but it's only for the security aspects. If they want to track a person, to know who is who, from where he's coming, from which area, from which place, who is his friends, who talking to, even the phones, they can track your phones, everything. So I think intelligence, it's more, it could be as my colleague mentioned, it could go to the privacy as well. There are so many privacy issues that I don't want to share where I am going to. I switched off the my location in the phone. So there are also privacy issues we have to take into consideration. It's not open that everybody, I will allow my information to give to everyone that I'm moving, I'm going to the work that time, I'm retaining that time. Some other people, black people, they will take it into another area. Anybody know?
Okay. It's okay. I think I have more than one point to make. I really loved your example. And whether it is with AI or without, I think it's a very nice example of actually understanding or seeing the problem with different eyes and finding solutions. And the question really is, how do you get there? The second point is, I asked before, what kind of roles do we have? And I think maybe we should also question a little bit our own role of being experts. What does it really mean, being an expert? Maybe the user is an expert like we are, because they know a lot, in what how they want to resolve their problems and where they feel comfortable and where they don't. And so I think also we as universities, are we accessible? Do we have the platforms to exchange in such a manner that we just discussed to find out? I would not say 100%, because we're experts. We're used to kind of, put through our expert knowledge. Maybe we need to think that through. And then maybe another point I want to raise, I'm not an expert in ethics, but I think there's so many open questions that we discuss, and I think without now taking too much of theory, is it really the world we want to live in? Or I think we have now also the chance to shape our futures. And I think that's several reasons why I would completely agree to what you said, that we have to involve the parties. And then how do we do it? Maybe we can also tie it back, because I think the fourth point that I'm making is it's so rewarding. Maybe, it was a huge necessity for you to invent that solution. And the background wasn't so nice, because hitchhiking is dangerous, but it created a solution. And you live in a context which is completely different from Switzerland. And I think we're talking about collaborations here. And I think there is so much fruitful or so much in that kind of exchange. We're talking about collaboration and exchange. And I think we can take a lot of profit from, trying to understand the different contexts in which we have to develop solutions, because that might trigger some new perspectives which we would not have done by ourselves. So,
I would like just to comment on the privacy issue Professor Qasimi has mentioned. Is that all these applications, involve circulating data over the network, we go back to the ICT support. It's computing, information, and communication technology support, finally, for all these types of applications for the users we are talking about. And data circulating over the network causes a privacy issue because analyzing this data may give actually information about the lifestyle of the users, which is, or other sensitive or critical information about the user that they are using the applications, and finally this data is on the network. So we have to be very careful about privacy issue, and therefore we go back to our role as a computer scientist and engineer to take care of introducing with the implementation of the application privacy preserving mechanism, which allows for these applications to be accepted by the users, because we are talking about how these applications also will be accepted, and without this mechanism the applications there is a hesitation to use this application. So this is very critical.
Thank you so very much. So I guess there is a lot of interest and there may be more questions, but since we do not have time, of course the questions may be directed to the speakers, the learned panelists. They've shared their knowledge. Thanks a lot for being with us, and we'll direct the questions, if there are any, to you through emails. So thank you so very much to all the audiences. I'll give the stage back to Mr. Dante. So please.
Thank you very much, esteemed panelists, for your intake this afternoon. We're reaching the conclusion of the event. Before we do so, I would like to invite Dr. Joseph Spielner to say a few closing remarks about the event. Then afterwards, we will move towards our networking reception. Dr. Spielner, the floor is yours.
So I think it was a very nice day. I hope you enjoyed it. We had two very interesting panels in the afternoon, and both brought up more points than they answered, because in each hour of panel you can answer maybe 1 or 2 points, but then you raise 10 new points. And I hope all of you took some notes. I very much liked the interaction that happened with the public, because you had shown that those are interesting questions that could turn into projects, and this is what we are looking at. So from repeating what was said in the more or less pre-lunchtime session from the leading house, the call will be published in May, but you can, of course, that is no secret, already now look at the previous call. It will be probably kind of similar, so you get the first idea. Then in May you get an official invite, and in end of August there will be the deadline. So we hope that a lot of Swiss as well as UAE universities will look at solving those problems together in mobility, logistics, but also water management and arbitrary other fields as well. Ideally, of course, involving other partners. They do not have to be strictly part of the consortium. It could be that two universities do a project and simply informally keep the contact to DIVA, RTA, BlaBlaCar, other companies we have mentioned today as partners of practice. So they are the ones that continue to be in the field, and that continue to have you have to imagine the projects will run next year, 23, though the commercial context may be already slightly different, and so you get, as researchers, always day-to-day updated input, and you can digest that in the projects. And of course, if you have any solution, then you can immediately have kind of an echo chamber. You can ask your links, is this a solution that could potentially, with a lot of research investment, turn into something useful, or is it something that is dead from the start? So I hope this is something that you enjoyed today. I think we will still be available, most of us, for a networking session now. Thanks a lot for coming here. Thanks a lot, Dante, for organizing the event for us today. And of course, the whole Swiss Pavilion team. You have been doing a great job on site, not just today, but in fact, many weeks beforehand. Thanks a lot.
Once again, when you said that the thing is that we are researchers, okay? We are teaching as well, but I'm a parent as well, I'm in a community, I have different roles, okay, during the day, during the week. For instance, for the schools, I have a vision because my children are there, they have to go to school on foot or blah, 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 etc. And the thing is that in 20 years, 30% of the jobs will be there. Okay. That's a fact. So, how to take that into account? Because it is always like we are only one thing. I am a researcher, I am a policymaker, or I am a user of that. But in fact, nobody is only a single thing.
I'll be very interested in measuring the energy, how much